With CodeFresh, we've rethought the CI/CD build and release process from the ground up for the world of microservices. As you adopt microservices, the number of pipelines you need to create and maintain skyrockets. Old build systems can't scale to meet the demand. But CodeFresh allows you to standardize your steps and package them in Docker images, then reuse them across multiple pipelines. You can think of them like a library of building blocks to build images, perform canary releases to Kubernetes, launch serverless functions, do security scans, UI tests, and so much more. And since the steps are Docker images, you can very easily create and use your own private steps or use images contributed by the growing CodeFresh community. Traditionally, the CI/CD experience has been pretty unfriendly, but we built CodeFresh to be a tool we actually want to use with a beautiful and functional UI throughout. In CodeFresh, you not only see pipelines and builds, but you also connect directly to your runtime environment and see what services you've deployed, and you can trace them back to the code and configuration changes, as well as seeing who worked on them and how they were validated. CodeFresh has an embedded Docker registry and Helm repository with integrations to all your external registries, so it's easy to manage and promote images and charts. When teams adopt CodeFresh, they release more often, and their engineers have more time to build their product, rather than building pipelines. That's why enterprises and startups alike love CodeFresh. Go to codefresh.io to create an account so you can start building your own pipelines, or schedule a one-on-one with one of our CI/CD experts to help you get up and running quickly.
Welcome to the Live at Manning conference for Kubernetes. We've got some great stuff lined up today. Take a look at the schedule down there below. If you're watching here on Twitch, you can see what's coming up. I'm going to kick things off here. No pressure, I guess, to start off the today's conference. I'm really excited to be here to talk with you a little bit about microservices and how to make them, if not bulletproof, more bulletproof, let's say. And this presentation, I've got a lot of help from team members Dennis and Craig. I want to give them a shout out there. Thank you very much for helping me prepare this session and getting it ready to go. Hey, that's my name. At the very top. Cool. All right, so let's get right into it, I guess, if that's okay. So microservices, right? That's the new big thing these days, right? And we're going to talk a lot about microservices and Kubernetes. A lot of crossover there. A lot of overlap, I guess. Microservices allow you to independently deploy and scale parts of your system. So if you determine that the user profile part of your system is being used a lot, for instance, if you have the traditional monolith system, you got to scale the whole thing. With a microservice, you can just scale the user part and not only scale the computing part of it, but you can also scale the organizational part of it. The developers who are working on it and the deployment can be independent of the rest of the system. But as shown by this tweet here, microservices are distributed, and that brings a lot of challenges with it. Monoliths are much simpler to develop. A single application containing all the features. So if I'm in the payment part of the system, I need to access something about a user, just a method call, basically. That's relatively easy and straightforward. But in a microservice system, we're going to split those parts up. And now I have to make an HTTP call to the user system. And there's a chance the user system might be down right now. And refactoring is not as straightforward. So if I add a new field to the user service or some new logic or whatever, I can't just go and update all the other services to take that into account. Some other team might be responsible for that payment service. So I have to have some sort of agreement or contract in place that I'm going to stick to that and make changes very carefully to that public API. Or internal API, as the case may be. Transactions are a problem too. So how can I guarantee that an update applies atomically when there's two different services that are separated by a network? So these are all the kind of problems that microservices introduce while they try to solve other problems. So really, no one wants to deal with microservices and all these extra problems that they throw at you. If you're a small team and you don't need to scale a lot in terms of teams, size, organizations, computing, deployment, then just stick with a monolith. It's totally fine. It's going to cost you a lot of time and money to build a microservice, and if you don't have a really good reason for it, then you're going to give yourself a lot of headaches. But if scale is a problem, and again, not just talking about servers, but scaling your team, scaling your deployment, scaling your company, then microservices might be a way to go, might be a way to help you. I'm covering up the quote here. There we go. Make sure I got attribution there. I work for Couchbase as a developer advocate, and I'm not an expert in anything really, but I'm very enthusiastic about technology, and I was really enthusiastic when Manning gave me the opportunity to write the book that I wrote, and it's you know, an older book, but some of the principles we'll talk about in it in this presentation today. It's not a microservices book. If you have other questions, you want to interact with me or comments or anything else you want to do, you can contact me on Twitter, mgroves there. I also, I'm a regular on Twitch as a live coder. I'm part of the live coders team. You can follow me at Matthew D. Groves there on Twitch. I usually stream about programming topics about twice a week. So those are very open office hours, interactive. It's not a slide-based presentation like this one. I'm also covering up attribution for this amazing depiction of me. Can you see the resemblance? This is the 2020 facial hair, but otherwise it's spot on, right? All right, so let's get into it. We're going to build some bulletproof systems. We're going to take our monolith and we're going to split it up and make it a microservice, right? Well, it's not as straightforward as that, unfortunately. So what happens is oftentimes you're going to start migrating from a monolith to a microservices. Maybe just one microservice to start with. And what you might see is that you start to develop a microservice as if it were a monolith. And what you end up with is the worst of both worlds. You're going to have all the problems you had before with a monolith, but now they're going to be distributed across the network. And this is okay. If this is where you are right now, that's fine. There's nothing to be ashamed of here. It's just one step in your journey. But just notice that we can't take the same approach to building microservices as we did with monolith. Microservices make up systems. So it may be a dozen services, it may be just two, but they all act within the same system. And unlike a monolith, they need to be autonomous, hence the name of today's session. So if you're relying on synchronous calls, for instance, I'm going to make a call to other service and wait for the response before proceeding, that's going to be trouble because the network is a whole new problem. So if the user service is offline, then I can't get user data. So I think it's better to think about microservices as if they were human beings. And we rely on each other all the time as humans. And my example that I've used is probably not super relevant in 2020, but I think of like commuting to work. And I haven't commuted to work in a long time, and a lot of people this year are currently not commuting to work. But just think about a hypothetical commute to work. And maybe we're taking public transit, we're taking the bus. And so we rely on another person, the bus driver, to get us from point A to point B. But during most of the workday, I don't really need to think about that bus driver. I don't need the bus driver to accomplish my job. I'm autonomous, the bus driver is autonomous. We rely on each other at some level, but if something happens to the bus driver, if he's late, if he skips work, if I miss the bus stop, then I, as a human, am autonomous enough to, okay, now I got to think of how am I going to deal with this? Do I wait for the next bus? Do I call a cab? Do I call an Uber? Do I call a friend? I have to think of these things autonomously. I can't wait on the bus driver for me to make decisions and go on with my life. So what does it mean to be an autonomous microservice? We're going to cover four characteristics here. The first one we've kind of already covered up, which is basically having microservices in the first place. So we slice up that monolith into multiple services and they communicate with each other. But that's just not enough on its own to be autonomous. So these other things I think are very important. We need to have isolated failure. resiliency, and elasticity. So how do we get those things in our microservices system? Well, we'll talk about isolated failure first. Basically, things are going to fail. We have to deal with that. We have to understand other parts of the system are going to have problems. Hopefully not very often, hopefully even never, but we have to act as if they could have problems. So imagine this hypothetical microservices architecture here, and all these services depend on other services and maybe even indirectly depend on the other services, but they're all kind of interconnected. You can see the arrows here that indicate the different dependencies. So maybe service 1 is me, service 4 is the bus driver. We depend on each other in some extent. But let's just imagine the user service here, right in the middle of architecture. It goes down or it's on fire. Something's wrong with it. It's broken, it's slow, something bad's going on here. So it becomes like a single point of failure because all the other services directly depend on the user service. And if that's offline, well, then we can't keep going. We need the user service in order to proceed. Something the user service is going to do, we can't get to it, so therefore we can't proceed. The whole system is now failed. So this is the microlith type of example here. Everything it's just a monolith, but it's distributed. So what are some approaches to solve this? There's lots. I'm going to cover a couple. The first one, one way to improve it is caching. So instead of asking for the data I need from other services, I can just cache what I need and cache that in a database or a cache that I have access to, that my service has direct access to. So what does this look like? So let's say that the order, delivery, and payment service, they all depend on a user service, just like I showed you in the previous slide with the fire on it. The user data we want to get from the user service. So maybe for delivery, we need their address. For payment, we need their payment information and their credit card and so on. So instead of contacting the user service directly, we set up some kind of asynchronous communication. So whenever a user is updated in the user service or is created or whatever, it's going to trigger some event, like a user updated event. And other services can listen for that, can subscribe to that event. And then those services can take the data from that event and cache it locally. You can think of it like a database, but it's a cache. It's just a local copy of the data that I need. And if it's the payment service, for instance, right up here, payment service, maybe I just need the user ID and the credit card information. I'll just take that. I don't need to store the whole user. I'll just store that part of it. And same with delivery service up there. If I just need the address and the user ID, I'll just store that part of it. And so this kind of architecture happens with something like RabbitMQ or Kafka or some sort of message bus there that the user service will publish to and other services will subscribe to. And services can publish their own information and others can subscribe to it and so on. Now, the order service could still go to the user service directly if it wants to and fall back to the cache, for instance, or you could go to the cache first, and if it's not there, then fall back to the user service. But either way, if you have a cache available, it gives you a window of time for the user service to get its act together and get fixed and get back online. So it could be a matter of seconds or minutes. It could be a day even, while the user service gets back together. In the meantime, we can still process our orders with the cache data that we have locally. Now, the drawback to this, and there's going to be trade-offs and drawbacks all along the way, that's just the nature of microservices, is that we could have some eventual consistency problems here. The cache data might be out of date for some period of time. So it's up to us to determine, well, how long do we keep this cache data before we either erase it or just consider it out of date and we can't use it anymore. Or, since it's not synchronous, right, the data may be on its way to updates, but I may be performing something in my service that's using the outdated data. But just think back to this metaphor of humans and being autonomous, is that real life is unfortunately not strongly consistent either. So if I've done this recently, relatively recently, I guess, is change an address. I fill out a change of address card, and I give it to the post office, or more likely it was a change of address web form. And I send that to the post office, but it doesn't immediately update every instance of my address in the post office's system. It may take hours, it may take days for them to figure it out. So in the meantime, stuff's going to be sent to my old address. So I need to make arrangements as a person. Well, I come by and pick it up on a weekly basis from the new tenants or the new owners. Or maybe I contact my credit card company directly and say, hey, I'm changing my address. I thought you should know about it. The post office will eventually get it forwarded, but I'm going to be proactive and figure it out. So I have to, as a person, act autonomously to cope with the fact that the post office may not be fast enough, or they may not get my form over the weekend. So other types of communication, we talked about asynchronous, and that's kind of the way you should probably go with this, is some sort of message bus or a queuing system to handle those things. And we as developers, and this is changing, I think, but as developers, we often think about things in terms of synchronous, right? That method call is synchronous. But most problems can be reframed to asynchronous, have an asynchronous approach. Streams is something that may be gaining some steam as well, some momentum, maybe like gRPC or something like that. But I haven't seen a lot of that in my experience yet, but that's something else to think about. So async really should be the norm between services, and only use synchronous when you absolutely have to. So it wouldn't be a microservices presentation without an Amazon analogy. So you're placing an order on Amazon, you get a confirmation email right away that says thank you for your order, and it seems really synchronous, right? But it's absolutely not the case behind the scenes. So there's going to be some sort of inventory that has to be checked. Like, do we have the item that he purchased? And where is it? Which warehouse is it in? And then a delivery service. So once we've marked something as, okay, this has been purchased, it's an inventory, we need to get it delivered. So we need to print out a delivery label for that and get it packaged and get it sent on the box and get it put on a truck. And then we have another service that is monitoring this and says, hey, your order has been shipped. Or, hey, it's been shipped, so now we're going to charge your payment method. So we can invoke a payment service. So what this means, though, is that even if the payment service is offline for a few hours during this process, I can still place an order. It can still be set for delivery. It's just that when the payment service gets back online, it's going to have to work back through that queue and get to work to catch up with this time offline. Okay, so if most of our communication between our services is asynchronous and we have some caching set up, then we can tolerate some failure. Maybe for a matter of minutes, maybe for hours, maybe for a day, but we can have some tolerance. We can isolate failures, and we can still go about our day. But our services themselves are not resilient. This is what I want to cover next. Which, by the way, if anyone in the chat has any questions or comments, I see a lot of you out there. Just feel free to throw those in there. I'll try to monitor the chat the best I can and read out those questions as they come in. So hello to everybody out there on Twitch and the chat. Great to see you. Glad you're here. Let's talk about making our microservices resilient. And what this basically means is don't let anyone else break your internal state. And thinking back to the example of humans as autonomous actors in a system, I don't know, does anybody still write checks anymore? You at least know what a check is, right? You're writing a check. I write a check, some amount that I promise to pay, and I give it to the clerk at the store. And then I walk away with the merchandise that I purchased. Okay? So what I then have to do is that check's going to take some time to actually clear my bank account. And so there's a process called balancing your checkbook, where you have to go and keep records of the checks that I wrote and make sure they match up with what's actually hits my bank. Because maybe I have sloppy handwriting, which I actually have terrible handwriting. So maybe that caused a number to be transposed or read incorrectly. So I have to match it up to make sure that they are consistent. So just by the process of writing down the checks that I wrote and the amounts that I wrote, I'm keeping an internal state. I'm not relying on the grocery store or the bank to get it right. Hopefully they will, but I will also double check with my internal state. So kind of the equivalent of doing this with a microservice system is event sourcing or event logging. This is a way of building the history of the state of some entity, like a checking account, or it could be user profile or whatever else. So you can build the current state by using the history, like an accounting ledger, or again, that checkbook balancing little piece of paper they give you with when you buy a checkbook. So let's say that some other team pushes an update to their microservice, and they wrote a bug somehow. I know it's hard to believe that developers write bugs, but that bug, or maybe a mistake in logic, it causes an inconsistency in the service or in the data that the service gives you. So now that system sends a wrong message, and I get that wrong message from them. So then I store that in my state somewhere. And now I start sending out inconsistent messages or incorrect data. And now we have a distributed bug. And this is the part where you have to think about, oh, well, now I have to solve a murder mystery. Just like I said in that tweet at the beginning of the presentation. I wanted to clear the screen so you can see this URL here. So we have a distributed bug. So what's the source of this bug? Who caused the bug? Where did it start? And how do we actually go through and debug it? Well, there's several approaches to this, and open tracing is one approach you might take. But another approach is event sourcing. This allows you to track the history and changes in your own service. So you can go back, and once you've determined there is a bug or a problem, you can go back and look at the history. You don't just see the current balance of your checking account, you see the last 100 checks that went into that process. So we can go through that and see, well, when was that inconsistency generated? And then we can see, oh, well, it came from service X. So clearly there was a problem there. What we can do now is we can, to fix that, we can add an offsetting record, add a new record to my history and say, okay, well, here's a correction. Or we could, go back in history and reprocess from some snapshot. So if you have not heard of event sourcing before or event logging, I definitely recommend you check out this blog post up here, which I just put my big head back in the way of. This has been a blog post. It's, I think, a year or two or ish old, but the pattern has been around for a long time. Definitely check out this post. It was written by Dennis Rosa, who I mentioned earlier in the presentation, that goes through the details of how event sourcing and logging works, the benefits of it, and how to get started using it. So I recommend that post for sure. We can do to keep our system resilient, keep our services resilient, is respect other services. And again, the people analogy holds up. Respect other people in the system. So let's look at an example in our microservices architecture. So we've got a web app, and it may need one or more of these services behind the scenes, one or more other microservices. So again, just think of those as like payment or ordering or inventory systems or whatever. And the web app, which is what the user, the customer, or whoever interacts with. So service 2 in this situation here is on fire. It's broken, it's down, it's slow, it's failing, whatever. It's in maintenance, who knows? Something's wrong with service 2. Now a customer comes in, uses the web app, and they happen to be doing some activity. Maybe they're checking inventory or browsing a catalog or whatever. And they happen to need service 2. So that thread in the web app is going to service 2, and service 2 is down. So that request is kind of locked up. It's waiting for a timeout, or it's waiting for service 2 to happen, and it's locked up, that thread in the web app. Other customers come in, make requests, and they're getting through just fine because they're not touching service 2 with whatever they're doing. And so they keep coming in, and they're able to proceed and get whatever task they want to get done with the web app, and everything's fine. Well, if you've seen this kind of situation before, you probably see where we're going with this, is that eventually this is going to lead to the thread pool getting exhausted. Because, depending on how many people are going to want to do tasks that require service 2, and this may be over a long period, this may be over a very short period, depending on how much that service 2 is being used. But the entire thread pool is going to get consumed. And now the web app is on fire. I love this little flame graphic, the way it dances around the screen. It's a lot of fun. But it's not fun for our users because the web app is on fire. So now we have cascading failures, Anything that doesn't need service 2, only needs service 3 or 4, it can't get through. Nothing wrong with service 3 and 4, but nobody can get through to it because the web app is entirely consumed and being blocked by service 2. There are a lot of different patterns and techniques to deal with this situation. One simple solution here, this is a snippet of Java, and if you're not a Java developer, don't panic. I'm not either, but this is just an example of Java code that will trigger this kind of problem because we have not specified any kind of timeout with this request, with either connection or the response that we want. There's no default read timeout for this, so this is going to lead to the situation we just saw, a bunch of threads in our web app getting locked up because service something.com/service1 in this case is on fire. So how do we deal with this? Well, the simple way to approach this is we can define a timeout. We can say, well, if we don't want to wait more than 2 seconds for a connection, we don't want to wait more than 2 seconds for a read. So then we can bail out very quickly. We know that service 1, we don't necessarily know that service 1 is down. Maybe it's just lagging, or maybe some intermittent problems. Maybe we could do a retry. We'll get to some other patterns here in a second. But in this case, we're not going to lock up our thread, at least not any longer than 4 seconds before we allow other requests to come in. There's other things we can do. There's a whole list here, and there's no way I can go through all of these, but a lot of other patterns and tools we can use to prevent these kind of situations. So a couple I want to point out. One is a circuit breaker. So a circuit breaker is basically after a certain number of failures, any more attempts to get to that service by anybody is going to fail immediately. It's not going to try and wait. It's just going to fail, done. Because we're basically saying, well, this has failed X number of times, so the service is probably down. And we'll try again later in, whatever timeout period you specify. Maybe it's 10 minutes, maybe it's 1 minute, whatever. Another pattern is a bulkhead, and this is basically just a way to prioritize the threads. So basically, let's say we have a really important service that needs the user service, and we have a less important service like maybe analytics or reporting or something that also needs a user service. What a bulkhead does is it allows me to prioritize and say the vital service is the most important. So it can get 80% of the threads. The analytics service, the reporting service, is not as important. We don't want it to take over a lot of threads, so let's limit it to, let's say, 2 threads at a time, or 10% of the threads, or whatever it is. We're going to put this stuff behind a bulkhead. So the analytics service, the reporting service can't bring down the system because it can only bring down 10% of the system, let's say. There's lots of other things we need to consider for this. Someone is calling me right now, and sorry about that. All right. So if you have followed microservices for a while, you're probably familiar with something called Hystrix. This is a framework that Netflix developed. Yeah, there's someone in the chat talking about chaos engineering. This is something that Netflix also pioneered along with chaos engineering to help with many of these things. And so this is what Netflix kind of created to deal with all those different those problems that the so-called chaos monkey was causing. I think that's what Bebo is referring to, or Bebop in the chat's referring to. He's asking, what about chaos engineering? Well, the chaos engineering, from my experience, is basically we're going to just pick services at random and shut them down and see if our system can see how it behaves at that point. Is it going to result in cascading failures, or is it going to be able to cope with that? And so Hystrix is a developer framework that Netflix published, and it allows you to implement a lot of these patterns we talked about to deal with making your systems resilient. And so this is fine, but it pushes a lot of responsibility over to the developer to try to handle those chaotic situations. And so that's maybe asking a lot. For every single service that you write, you have to, as a developer, think about those situations. Like I said, with the timeouts and things like that. The other problem with this one is that it's Java only. And I haven't mentioned this much yet, but one of the benefits of microservices is that each service can be written with the tools and technologies that are most appropriate. So if we're using Hystrix, that means we kind of have to use Java. So we have to find something else if we want to write a .NET Core microservice or a Python microservice. And so for these reasons and others, this project's kind of in maintenance mode right now. It's open source, it's out there, but it's not being actively improved or developed. So what we have instead is a pattern called the service mesh pattern. Maybe this is called some other things like a sidecar pattern or whatever else you want to call it. Um, Instead of the microservice itself handling all the network issues and the retries and the timeouts and things like that, we deploy a little application in that sort of same pod, that same box there, and it just acts as like a proxy to the other services. And actually, this is the section where it's most relevant to my book that I wrote a while ago, is that this is a way for us to implement cross-cutting concerns across all of our microservices. So there's a circuit breaker. We don't have to build it into our service. We don't have to code the circuit breaker. We just run it through the service mesh, and it will handle the circuit breaker stuff for us. Various requests to different URLs or different endpoints are going to be throttled or limited at the service mesh level before they talk to other services. Let's see, we've got a question coming in. Where is it best to set the CB, either as fronting the service or at the edge when calling external service? I'm not sure what you mean by CB in this case. Yeah, I would say maybe both in those cases. Depending on how your structure is, right? So if your circuit breaker, sorry, I guess that makes sense. Where is it best to deploy the circuit breaker? So, if your organization is treating microservices with different teams, then you can think of the circuit breaker. You can think of those other services as external services. So you can put a circuit breaker there, and you can put a circuit breaker in front of external services. So that's going to depend on where you want to, where you think those circuit breakers are going to work best. If your team is working on multiple microservices, you still might want to put a circuit breaker in there just in case. And just because it's there doesn't mean you necessarily have to use it. It's just that service mesh with the circuit breaker, other patterns are available if you want to use them. And so here's some of the more well-known service mesh providers. I think these are all still relevant. I'm not 100% sure. I know Istio is a relatively popular one. There's other ones out there, Linkerd and Envoy. And I think Microsoft has a relatively new one called DAPR, DAPR, if you're interested in that one. But these all provide various cross-cutting concerns. Excuse me. Externalized configuration. So maybe you want to include credentials and network locations, external services. You can store them in there. These might handle logging. So, sorry, they can configure logging frameworks like Log4j or Log4net or whatever you want to use for that. They can do health checks. So maybe a URL that a monitoring service can ping to get the health of the application. Metrics, I'll show you a little screenshot of metrics here in a second. So just some insight into what the application is doing and how it's performing. So the number of requests it's making, number of requests it's receiving, all those sorts of things. And distributed tracing, I kind of mentioned this early on, but open tracing is one thing we can use for this. And these tools also provide some level of tracing so that any external request has a unique identifier, and that's passed around between services. So we can follow the evidence and solve that murder mystery much easier because we can just follow that token around and see where the problem was. These tools also come with monitoring. So as I mentioned, Hystrix is like a Java framework, but let's say you're using a .NET or a Node service, you got to use a different tool. So if we're going to use one of these service mesh providers, they are language agnostic. They just sort of they interact with these services via network requests and responses. And so then we can get analytics from those tools. And we can generate reports like this where we can see requests per client and what's the retry rates and what's the speed of the responses and all those sorts of things. We can look at that with these independent tools. And these are not tied to any particular framework or language. So we can use them with .NET or Node or whatever. So we've made our microservices resilient with event sourcing, things like event sourcing, timeouts, circuit breakers, things like that. So we're improving the resiliency of our microservices. And this is where you're going to spend a lot of time probably making sure you get this right. And I believe there are some of the snippets that I identified. So if you registered for this conference, I've identified snippets from a few books, from a few Manning books that cover these patterns, event sourcing and others. So you definitely want to check out some of those books. I actually, this is another book I recommended, which we're going to cover in a second here, but the Kubernetes in Action, there's currently a early access program for the second edition of that book. So I think that's one I've also identified. If you've registered for the conference, you can check that out. But that's the last one I want to get to is elasticity. We're going to talk about how do we make our services elastic. And elastic means we're able to scale out a service. Now we're talking about computing to accommodate more load. Now the patterns to deal with this is basically service discovery and load balancing. You're probably familiar with these from even outside the world of microservices. So when a new service is deployed, it has to tell some service registry that, hey, I'm on here, I'm online, I'm ready to take whatever work you have sent my way. And when a service is needed, the service registry can be asked, oh, hey, which instance of this service can I call? Now, this is a pattern that you can do with load balancing and various service registry tools, but it's something that for microservices, we're kind of leaning on Kubernetes to do a lot of this for us. So Kubernetes, we can get kind of the same thing using the Kubernetes services, which is a logical set of pods, which you can think of as instances of a service. And we can define a service in Kubernetes, and it's going to direct whoever's making the request of the service to one of those pods, one of those instances. So you can see an example here of how you might configure that in Kubernetes. And then auto scaling is something that's available in Kubernetes. Some people are comfortable with this, some people are not. But basically, it's just one way we can tell our services to be elastic on an automatic basis. So for instance, manually we can say, well, this service, I need 2 replicas for the service. I need 2 Nginx instances to handle the web traffic. And I can just change that number from a 1 to a 2, or from a 2 to a 3, and so on. This replica's number right here. I don't know if you can see my mouse or not, but I'm highlighting it there in addition to that underline. Another option I can use is the pod autoscaler. So it can detect some situation and launch another instance. So if these 2 replicas are at 95% CPU, for instance, well, maybe that's the threshold where we automatically say, okay, let's put another replica up there. This is something that you can do, by the way, without Kubernetes. You can do it with just like Azure or AWS or whatever else. But this approach with Kubernetes is kind of gained popularity because it's cloud agnostic or cloud native, as some people might say. So anywhere you can run Kubernetes, including Azure, AWS, or even your own data center, you can run this logic. So you can now span multiple data centers. You can switch between them with relative ease, I guess. It's never really easy to switch from one cloud provider to another, but this will take you a step in that direction. And so at that point, we can now use Kubernetes to handle our elasticity for us. It can scale our services either automatically or in a very easy declarative way by just changing a number, which I will actually have a really quick demo for you here later, assuming we have time. So we've got all the boxes checked, and we're all ready to go now. Our microservice is highly scalable now, right? We're all done. Easy as that. Well, we're forgetting a big part of the system, and that's often overlooked, is the databases. What about your database? How do we achieve those same things with our database? And just in my experience, in my career, I've seen the databases have been the bottleneck of most applications. Wouldn't it be nice if we could just store everything in memory and it would be blazing fast, no matter what language we used? Just pull it from memory and away we go. But unfortunately, that's not the way it works. We have to store some data. We have to persist data. So it's important to take databases into consideration for the performance of the entire system. So we have all these autonomous services, but maybe we're not following all the microservice patterns, and they're all talking to the same database. Um, there's something called the database per microservice pattern, which kind of says that each microservice should have its own data domain that it exclusively has access to, which we could still follow with this, but maybe they're still on the same physical database. They're all different database catalogs, or they're limited to a certain portion of the database, but they're still on the same machine. So we kind of run into a problem now where all these services are interacting with the database, but the database itself is not very elastic. And scaling, if we're using a relational database, this becomes challenging. We could certainly have a vertical scaling where we just get a bigger machine, faster machine, more memory, more processors, and vertical scale. And that's easy in quotes, but it can be very expensive. And it can also potentially, depending on what types of queries you're running, it can hit a ceiling of, well, we can't scale beyond this point. And then, so the other approach is to scale horizontally, like we're doing with the services in Kubernetes. But with relational, that can become very challenging as well, especially if you've not designed your relational schema to do that from the beginning. And so I mentioned this earlier in the presentation, but we have this idea of polyglot persistence. So with microservices, it opens up lots of polyglot opportunities. We can use the right tool for the right job when we need to. So we have, in this case, 4 services, and maybe we build them like this. We have a Python service that's really good for some natural language processing, some great stuff in Python to do natural language processing, NLP. So we build that service in Python. And then we've got a Java microservice that contains the business logic we've built up over the years, or maybe even wraps some mainframe logic we've built up over the years. And we don't want to, that's very expensive to transition away from that, as we've seen in the news this year, actually. And then we have some .NET services. Maybe they were brought over in an acquisition, and we don't want to have to rebuild those to a new language, so they're out there and they're valuable and they're written in .NET. And then there's just that one team that loves JavaScript no matter what you tell them. So there's a service out there in Node. That's just a joke, JavaScript people. Don't get upset. I'm just kidding. So we have these services in different languages, and we mentioned the tools that we can use to act as service meshes that can live with any language, right? We're not using Hystrix that would be limited just to Java, but we're using a variety of tools. We can also do the same thing for persistence. So maybe for our financial records part of the system, we're going to stick with our relational, our business logic, our Java application that works fine with our Oracle database. We have another part of the system. As we peel off parts of our monolith, we determined that a user profile system could be a microservice. And so maybe that's better to use a document database, and we're going to use a Couchbase as our persistent layer there. Maybe have a third part that's doing some fraud detection. And graph databases are really good for finding outliers and detecting fraud. So we're going to use something like Neo4j here. And we could use a relational database for that as well, but since this service is responsible for fraud detection, why don't we just use the best tool for the job there and use a graph database for that, and use a document database for a user profile, because we need the flexibility of the user profile. And so a schemaless JSON database makes sense there. And for a search engine, again, we could use a bunch of like statements in our SQL query, but maybe a text search engine like Solr, or again, Couchbase has a text search engine built in, could accomplish that better for maybe searching our catalog, things like that. I don't know if you're going to be able to hear the audio from this clip here, but has anyone seen this clip before? This was back when we used to be able to get together in larger groups without wearing any sort of protective equipment. Yeah, no sound. Okay, that's fine. The sound is not super important, but if you want to watch this clip, you can go to that URL on the top right of the screen there. And I'll tell you what this is in a second here, but I just want you to get an idea of the scale of what's going on here. This massive group of people. What's actually happening is a Vaporeon spawned in Central Park, and this is a Pokemon Go. I'm not much of a Pokemon Go player, but this was in the early days of Pokemon Go. And yeah, Couchbase release. Yeah, that's what it was. They are all flocking to the new version of Couchbase. No, these are people who are trying to capture I guess, a rare Pokemon, Vaporeon. And this kind of brings me to the story of Pokemon Go, in that Pokemon Go, if you remember back in the early days of Pokemon Go, there was a huge spike in interest, a huge amount of signups in a very short period of time. We go from basically 0 to 300 million-ish users in a few short weeks. And so just imagine, and this exceeded, by the way, exceeded their expectations. So they weren't even prepared. They were prepared for a large scale. They weren't prepared for that large of a scale. So just imagine the costs and the effort to scale from 0 to 300 million in just a few short weeks. And Pokemon Go has kind of dropped off in usage, since those early days. But that's the kind of problem that maybe drove some of those people away early on, unfortunately. That, hey, I can't get into this system because it's so overloaded. It is not scaling well enough. Now, not everyone is a Pokemon Go, scaling up to many hundreds of millions of users. But it's not just about, again, it's not just about scaling the hardware. And I'm sure Oracle could probably come in and deliver that kind of scaling and performance. But how much is it going to cost to get it done in a 2-3 week period? If you look at a NoSQL database option, that may cost much less, not just because of the licensing, but also because of how it scales. In that you don't have to rework your logic to deal with the way a relational database scales. You can scale out. These databases are designed for scaling horizontally. So with polyglot databases, sometimes it's about the right database. You could use the relational database to work with graphs, as I mentioned earlier, but chances are a graph database is going to do the fraud detection work better. And sometimes there's other trade-offs involved, like cost. So this is, of course, I have to mention Couchbase here. This is just my sort of obligatory Couchbase plug. It's a NoSQL JSON document database. And document databases in general and Couchbase specifically are a common replacement for relational databases, and not in the sense that I would say always replace your relational database with Couchbase. No, of course not. But it's a replacement in the sense that if you haven't used NoSQL before, but you're interested in a more elastic scaling database system for microservices, then this would be a good place to start because it's designed for that kind of scaling scenario, and it also has SQL as a language. So if it's something you're used to writing SQL, and you're used to writing joins and group by and union and all those sorts of things that you like in relational, you can do that same thing with Couchbase. And so as you move towards microservices, you slice up your monolith, it may make sense to use Couchbase with some of those microservices, like the user profile, for instance, that I mentioned. It's a great fit for that, or a text search use case where you want to search through a catalog. So that brings me to what I'll talk about with Kubernetes operators. So if you've not heard of Kubernetes operators before, these are they sound very complicated, but they're really straightforward at kind of what their purpose is. It's an application-specific controller that sits on top of the Kubernetes API to manage instances of stateful applications, like databases, for instance. So you could have, for instance, a Couchbase operator. You could have a MySQL operator. You could have, a Kafka operator, a RabbitMQ operator, things like that. Now, just to say this up front, you don't need an operator. But I will say, if there's an operator available for the technology you want to use, you should almost definitely use it. Otherwise, it's going to be a lot of extra work inside Kubernetes for you to manage all that elasticity and the clustering, all those things yourself. So here is an example of a Couchbase cluster. I'm not going to go into huge detail here. This is not a Kubernetes tutorial by any means, but this is the definition of a Couchbase cluster defined in Kubernetes. And notice that there's a size here of 2. And this tells me how many nodes, how many Couchbase servers go into this Couchbase cluster. So when I say horizontal scaling, that means adding more machines, more servers to a cluster. And that cluster kind of acts as one individual database. So since I have this operator in place, if I want to increase my Couchbase capacity, I can just change this number to 3. To do this without an operator is going to require some extra work, some scripting, maybe some manual steps, things like that. But the operator is going to handle that for you. This is the operator, just the YAML file for the operator itself. Actually, what I'm showing you is kind of an older version. It's version 1.2, I think. Again, this is not an operator tutorial. I think version 2, Couchbase has version 2, and Couchbase was actually the first NoSQL database to really to publish an operator. So they're kind of the most mature NoSQL Kubernetes operator out there right now. And these are the kind of things that your operator will give you. And I think some of these things are in version 2. If not, they'll be in future versions. So I'm not 100% sure. But you get things like automatic backups and automatic upgrading to newer versions of whatever database, in this case, Couchbase, right? And again, I want to just kind of emphasize this. You could do these things without an operator. You'd have to do a lot more work yourself. But unless you have a really good reason to, I'd say stick to the operator and use the operator. All right, so I want to show a little bit of, not code, but a little demo today of an operator and Kubernetes kind of in action. So what I've got here, I brought up my Windows terminal screen here. Hopefully that's readable enough for you. So I'm going to just get a list of all my Kubernetes resources. I'm running this on Microsoft Azure and AKS. So you can see I've already taken some steps here. So I didn't want you to have to sit around and basically wait for a loading screen. But I've already deployed a Couchbase cluster out here. There's 2 pods of Couchbase, so it's a cluster of size 2. And some other things, I got some secrets in place with like credentials. That's how you can store them in Kubernetes cluster. And I've got some of these services here defined in Kubernetes as well. So what I'm going to do now is I'm going to open up the Couchbase cluster here. And this is just a YAML file that declaratively defines how you want this Couchbase cluster to look. Now, this is using the operator. So one of the things you'll notice here is there's lots of Couchbase specific things in this operator. So like data service memory quota, that's a Couchbase setting. The buckets I want in Couchbase, that's Couchbase specific settings. If I'm trying to do this in Kubernetes without an operator, then I have to do a bunch of other stuff to basically define that manually and just use the native Kubernetes API. CRD, someone commented, yes, that stands for, if I can remember this, that stands for, shoot, I just looked this up right before I started the presentation and I forget. Oh, resource definition. So this would be a Couchbase resource definition, or custom resource definition. Yes, sorry about that. So anyway, if I wanted to change this from 2 to 3, that's it, I just did it. Now, then I have to go and deploy that. CTL, update, and then I'll say Couchbase cluster.yaml. Oh, not update, sorry, it's replace. I'm still not getting it right. What's going on here? Let me just go back. I'm getting the syntax wrong. Okay, sorry, the -f goes after replace. There we go. So then I'll replace that definition. And it's going to take some time, but you're going to see in a second here that this will go from the 2 pods that were created here, and it will show a 3rd pod. We're not going to necessarily just sit here and wait for that. Oh, there we go. So it's not ready yet, but there it is. It's being defined, and it's about 5 seconds old. So there, I'm just scaling up my Couchbase cluster by just changing a number from 2 to 3 declaratively. If I'm doing that manually, that's a lot of steps, or a complicated script that I have to write to make that happen. Now, next thing I want to show is kind of a microservice in action. And I have the source code for this if you want to take a look. It's not terribly impressive, but here is a Spring Boot app. This is, I think, an older version of Spring Boot. It's just a web service that's going to do some user profile type of things. And so I'm going to, I've defined a YAML file which uses this Docker image right here. Really, really simple example. And so I'm going to, let's go back here. We're going to create, and I'm going to give it that YAML file, creating that app there. And you can see that it's already running very quickly. There's no state involved with this. It's just a really lightweight web app, so it's up and running almost immediately. So we can then, I can go ahead and, I'm not going to create a service for that and expose it to the public, especially not here on this live stream, but I can set up some port forwarding to tunnel to that. That was fake. Spring is not booting that fast. Oh boy, wow, really sticking it to Spring Boot. So there we go. I'm going to port forward over to that Spring Boot instance. Notice I'm just giving it the name of the service here. I'll port forward to that, and then I'll bring up, unless I closed it, I must have closed my browser window. Sorry about that. Now I can access it locally here on my local browser. It's just tunneling over to Kubernetes on AKS, and then I can say /users and get a list of users here with just that endpoint. So there we go. I've got a simple user profile API being built right there. I can do the same thing with Couchbase. So I'll just port forward over to this one. And we're going to go 91, and that'll set up port forwarding to Couchbase. And I can just, again, hit that locally. From here, 8091 is the port we use for Couchbase. And I'll just log in with my highly secure credentials of administrator and password. And I'm zoomed in here, but as you can see, we've got 3 servers. And I should have done this earlier to show you that there was 2 here, and then the third one was added automatically. But I've got 3 servers there. And what I didn't show you yet is that Spring Boot service that I'm running is also just generating records, fake records on a regular basis. So, wow. So the number of items here is going to keep increasing gradually as we go. So you can see that the service, if I wanted to scale that out, I could add more replicas here to Spring Boot. Now, unlikely if I'm going to expose this to the public, I probably want to put a load balancer in place. I'm not going to go through those steps there, but same sort of thing. I just change this number to 2 or 3 or 10, and Kubernetes is going to create all those instances for me. So that's the Elastic demo. That's showing you some of the benefits of using Kubernetes for elasticity. I'm not seeing any questions in the chat yet, so I think I'm just about ending my time anyway. I'm going to switch back over to the slides. Happy to discuss that further if anyone's interested. There's lots of other operators out there, so if you go to operatorhub.io, you'll see lots of different options for other tools out there. Generally speaking, some of these are community-driven. A lot of them are enterprise-driven, so they're for enterprise versions of these databases, right? And some of them aren't official even, so just take a look and see who's providing it and the licensing, things like that. But I think ultimately, if you're using Kubernetes and you're deploying to Kubernetes, you're investing in Kubernetes, the operator is really going to be the best way to go in terms of deploying databases to Kubernetes. Some other steps, if you want to learn more about Kubernetes or Couchbase, here's some free resources for you. So Couchbase itself, if you want to learn more about that, it's a free download. The Enterprise Edition, totally free to download and evaluate as much as you want to. And there's a Community Edition as well, which you can also deploy to production without buying a license. We've just announced today, actually, this very day, the Couchbase Cloud, which is Couchbase Database as a Service, which is pretty cool. And I don't think it's saying it's stepping out of line to say that we use the operator behind the scenes to handle those instances, because we're sort of dogfooding the operator, which is really cool to see that being used behind the scenes. Some free training for Couchbase. If you want to learn more about the operator, there's a URL for it right there. Lots of Couchbase blog posts. You can go and I've just linked to the ones that are tagged with Kubernetes. You can use that there. And technical questions you can ask on the forums. I actually published a blog post that's a little more technical, detailed about how to build an ASP.NET Core microservice and get started with that to build that locally. And then there's a second part of it actually deploying to Kubernetes. So you can definitely check those out. I'm seeing in the chat here that I'm being invited over to the Discord server for more questions. I will definitely go over there and answer any questions and discuss anything else you'd like to do. I'm also blocking my information here again. Here, I'll just turn off my camera real quick. Boop. So if you want, you can use me as a resource as well. So if anything looks interesting to you, you have questions or feedback, you can contact me on Twitter, on Twitch. Again, definitely check out some of those office hour streams. Those are really fun. Not formal like this, but very informal hangouts, and we're coding and we're learning things along the way. And of course, you're welcome to email me directly at my Couchbase address. This is my gorgeous family on our last vacation, which was on a cruise ship, and we love cruises. They've been delayed a few times this year, unfortunately. So this is a really happy memory. So I wanted to post this in the slide there. Right before I say, everybody, thank you very much for coming. I will definitely check out the Discord server. I will join that and answer any questions, continue the discussion. But I encourage you to stick around for some more great content here from Manning today at the Kubernetes conference. And hopefully you've registered, because you're going to get some goodies from Manning for doing that. So you definitely want to check that out. So at this point, I guess I'm done. I will see you over in Discord. And thank you.
Hi everyone, my name is Adrian Goins. I'm the Director of Community and Evangelism at Rancher Labs. See, it even says so right there. When they asked me to do this lightning talk, I wanted to choose a subject that was fitting for the time restrictions. A lightning talk is fast, it's under 10 minutes. Kubernetes doesn't have a reputation for being fast, but you know what does? K3s. For K3s, 10 minutes is a lifetime. I can do 10 installations of K3s in 10 minutes, and that's while eating a sandwich with one hand. In fact, let's start one now. K3s is easy to install using a tool called Ketchup from Alex Ellis. This installs K3s over SSH, similar to how RKE does it. What's RKE, you ask? Why, it's our other CNCF certified Kubernetes distribution. It runs everything inside of containers. You should check it out. But this talk is about using MetalLB with K3s. So I need to disable service LB and traffic when bringing up the cluster. There we go. While that's building, let me explain what I just did. K3s ships with traffic for its ingress controller, and it uses Clipper LB to attach a load balancer service to the IP of the host. This is great for installations where you only need one thing bound to a single IP, but what about when you need multiple IPs, or when you have more public services than you have nodes? Enter MetalLB, the only solution for load balancer services in on-prem K3s deployments. You give MetalLB a block of addresses like you would with a DHCP server, and when you create a load balancer service, it grabs one of those addresses and begins announcing it either via layer 2 ARP or BGP. If a node goes down, it starts announcing it from a different node. MetalLB used to depend on Kubernetes for failed node detection, and that could take up to 6 minutes to detect a failure and move the IP. Now it uses memberlist from HashiCorp for fast detection of failed nodes. Now that our node is up, we'll install MetalLB and then the Nginx ingress controller from Helm. MetalLB is easy to install with Kustomize. It'll pull from the GitHub repo, and the only two files that I need locally are my config map that specifies the address pool and the secret that defines the passphrase that memberlist uses for communication between nodes. We'll fire that off with kubectl apply-k, and while it's rolling out, let's talk about Nginx. Don't get me wrong. I like Traffic and the team at Containus a lot. They're doing great things with V2 of Traffic, but K3s deploys 1.7 to keep things lightweight. I could redeploy either of them, behind MetalLB, or I could deploy HA proxy, or I could deploy anything else. I'm only showing how to deploy Nginx because it's so common. Everybody already knows how to use it. Now, you've probably heard of a thing called Helm, right? You install the Helm binary on your local machine, you add repos, you update them, and then you install applications with a bunch of --set flags or a values.yaml file. This sounds familiar, yeah? Well, check this out. K3s has a Helm controller, which means that we can deploy packages from Helm by applying a manifest to the cluster that looks like this. The spec contains the chart, the version, the repo, the target namespace, and optionally any parameters that we want to set. You can drop these files into a directory on the K3s nodes, and they'll be automatically deployed, or you can apply them to the cluster like a regular manifest. Hello, GitOps. So where does that leave us? It leaves us able to kick off an install of something like an MQTT broker. That would get its own IP for direct communication with the service, and clients won't have to pass through something like the TCP services configuration of an ingress controller or a dedicated external load balancer. If we did that, it might look like this. And installing it, well, it might look like that. So what comes next? Well, after this talk, I'm going to turn this into a multi-node cluster and start installing other apps on it. And then I'm going to import it into Rancher to start managing it. But this is my cluster. You should go build your own, and you should do what you want to do with it. K3s and MetalLB are free and open source, so there's nothing holding you back. Come join the K3s revolution and start making Kubernetes work for you.
Rancher is the market leader in open-source cloud-native Kubernetes management and allows you to manage and scale workloads consistently across thousands of clusters in any environment and support any certified Kubernetes distribution. Monitor the health of all your clusters through a single pane of glass. Simplify and automate the deployment and management of containerized applications. Deploy persistent storage with just one click, and simplify global access control and security policies for your entire Kubernetes environment. And because Rancher is 100% open source, you can achieve all of this at a fraction of the cost of legacy solutions. Kubernetes is the key to unlocking digital transformation. Rancher is the key to unlocking the full potential of Kubernetes. Schedule your free no-obligation consultation today.
Hello out there. I'm Brian and this is Erik St.Martin, and we're excited to do some pretty crazy demos. Look at our video. It's not really...
It's just me.
It's just Erik. So I'm Brian and that was Erik, but I'm not going to be sharing...
There we go.
Much better. Okay, good. So I'm Brian, this is Erik. We're going to be doing some pretty cool demos and talking about some crazy ways that you can abuse Kubernetes to run WebAssembly using a project that we've been contributing to called Krustlet. And it's a fun project, and we really wanted to find a way to demonstrate the capabilities of this project that weren't your average hello world. So
yeah, a lot of the components and patterns inside Kubernetes are super useful as far as, you know, these control loops and things like that. So we wanted to kind of use it to control other things aside from containers. So,
and just in case you're curious about our social distancing, Erik and I are neighbors, so you know we're already broken into the social distance family. It's okay, so don't feel bad for us. All right, so let's move into the problem statement. We are in Mars. And we've launched a rover out there, and Matt Damon is unfortunately stuck on the surface of Mars. The rest of his team has abandoned him because there was a big storm, And Matt was left for dead, but apparently he's alive, which
We have
is
no way of communicating with him.
We've got no way to communicate with him. This might sound familiar if you saw the movie The Martian. It might not if you haven't seen the movie, but we're stuck with no way to communicate with Matt. What we do have on the ground is a Mars rover, and it looks a lot like this.
We've got a robotic arm there.
And
so
our robotic arm represents our Mars rover.
Yep, we're going to over-engineer the crap out of this thing, and we're going to schedule WebAssembly to the node that controls the robotic arm and get it to point at hexadecimal digits so that we can communicate with Matt Damon.
Yeah, because fortunately, we did happen to have a Kubernetes network between us and Mars.
And robotics to play with.
And robotics to play with. So the good news is we're going to do our best to rescue Matt and communicate with him, but it's going to require WebAssembly, Kubernetes, and some Rust, and good old-fashioned over-engineering of everything. So let's start with the basics. What we're going to do is we're going to build a website that allows us to talk to, what am I switching?
Desktop.
Thank you.
There we go.
There we go. We're going to build a website that allows us to submit messages to the Kubernetes pod that's running our rover controller. And that website is hosted on Azure Static Web Apps. So let's take a quick look at the end result. Looks like this. Can't quite see. Let's escape this. Make it a little bit smaller. You can see the whole thing. There we go. So this is what the folks at Houston are going to use to send messages to the robot. And then Matt Damon's going to be able to translate those hexadecimal characters into ASCII and string together some English so we can actually talk to him.
We don't know how he's going to talk to us yet.
Yeah,
But,
we haven't figured that part out. So let's take a look at the website that we've built. A really simple website in Svelte, which is my favorite JavaScript site building tool. So it's got one Svelte file, app.svelte, and the HTML bits of it have an input box for our message and a button with a little bit of state so we can determine whether or not the button has been clicked and whether we're waiting for the send to finish. I went all out in my JavaScript skills. In fact, I think I maxed out my JavaScript skills by adding this typewriter function. So when you type something, as the message is being sent, it will type right across the screen. And then up above in the Svelte component section, we've got a little bit of state management. We want to determine whether or not somebody has clicked submit, and then a little bit of a function to translate ASCII into hexadecimal. And then the last thing we're going to do is transmit the message to our moderation server. And the moderation server uses Azure's functions because we know that this stream is PG or maybe even G rated. I'm not sure which. We're not going to go above G, but it could be PG, I suppose. The last thing we want to do is have people submitting messages to this robot that are inappropriate. So we're going to use Azure's Cognitive Services Content Moderation Service in order to make sure that the messages aren't unfriendly to people out there. So this will give us a score, and if the message doesn't pass the score, then it won't get sent off to Mars. We don't need our astronaut out there getting more stressed than he already is.
Yeah, and if we have time at the end, we'll let all of you send messages to the rover. You can trick the content moderation thing. Please be nice. This is going to be recorded.
Be nice, or we'll shut it off because we can. All right, so let's walk through this really quickly. So we've got a application, and the input message is bound to the message function. When you hit the button to submit, it's going to call the handle click function up on the top. Handle click uppercases the message because the range of ASCII and hexadecimal translations is too wide, we only want to deal with uppercase, then we'll moderate the message, and then after it's moderated, we'll send it using the transmit function. And that will go off to rover.brian.dev, which is a DNS name for the router in my closet, just over there. And we've got a laptop just behind the screen over here connected to our robot. And let's give you a quick sneak peek of that. Here is our Mars rover. And you can see we've set up flags for each of the available ASCII representations of hexadecimal characters. So the end goal is we want to translate these messages from ASCII to hexadecimal and then send commands to the robot to point to the right characters so that poor Matt, while he's stranded on Mars, can translate those messages and write them down and figure out what's going on. All right, so what we end up with is our website like this, and if we type in stuff and hit send, it will send it somewhere. But we need to get through the deployment of this web app first. So let's take a look quickly at the repository for the web app. It's on my GitHub at bketelsen/SWACOG, Static Web Apps Cognitive Services, if anybody's curious what those stood for. And this is built with Azure's new Azure Static Web Apps, which we announced a couple weeks ago at Build. Really excited about this. It's a kind of a one-click deploy for static web apps that lets you connect a GitHub repo, and then it creates a GitHub Actions workflow. This Actions workflow will build your web app however static web apps need to be built. If you're using Hugo or Jekyll or any of the static app generators, or if it's just an NPM build, it can do that too. And then with just a few configuration lines here, it asks us where our API code is and where the result of our deployment is going to be, which is public in our case. And then the GitHub action will deploy that every time we push to production. So, or push to GitHub, I'm sorry. So if we look at the result of this deploy, you can see that it runs the Svelte build right here. It does a yarn install. Oh, it's a little bit small, I apologize. And it creates main.js, puts it out into the bundle. We end up with a public directory that's populated. And right at the end.
Oh, switch. You're still on that.
Oh, my bad, my bad, my bad. Here we go. There we go. And then right at the end of this, you can see it tells us what the URL for our site is. So Azure Static Web Apps gives us a URL at azurestaticapps.net, and you can also configure that to go to your own domains if you want to. So I have a domain in my DNS, and I think it's Houston.ketelsen.dev. See if that works. No, DNS not resolving yet. Give that some time to resolve. And let's go look at the back end of this. So,
so if you're familiar with the Kubernetes architecture and the control plane components, we've got one of the core components is the kubelet, which is the agent that runs on the node. It's basically looking at the API server, looking for workloads that have been assigned to it, and then doing all of the bits of pulling down the image and executing it using the container runtime. Most people are using Docker. So what this project does is it stands in place of that kubelet, and it looks for workloads, except it does not talk to a container runtime. It talks, well, embedded within it is a WASM runtime. So we're going to execute WASM directly on the node, not inside of a container.
Yeah, and it's really exciting. It's kind of fun. So if you're familiar with the virtual kubelet, which we built late 2017, 2 years ago, yeah. 2.5 years ago now. It's a similar model. We're just pretending to be a kubelet and interacting with the Kubernetes API that way. Except this time, instead of writing it in Go, we wanted to see what it felt like to write it in Rust. And
The two primary motivations for Rust are, one, it has very good WASM support right now.
and that's a big number one. I mean, the WASM support in Rust is just better than everything else.
And then number two, ideally, this would be really cool to see on embedded hardware, not needing an OS, just running natively on an ARM processor. So Rust will get us there too.
Yeah.
There's some stuff in Go, Tiny Go, and things like that that probably could have been used for that, but then you kind of lean into the WebAssembly support, and Rust still has the best.
Yeah. So we have this running, just as an aside, we have Krustlet running in Mac OS and Linux now, really easily in Windows with a little bit of effort, and it runs on Raspberry Pi 64-bit. So if you're running a Pi 3 or 4 with a 64-bit Ubuntu or Raspbian, you can run Krustlet. We don't yet have it running in native ARM devices, but it's coming. We're getting
trying.
really close. So that's really exciting.
So
So
probably talk about why WebAssembly, why that's a good,
yeah,
why do we even want to use that in place of a container?
that's a great segue into why to do this. So one of the things that's interesting about the WebAssembly model is that it already has a really strong sandbox built in. WebAssembly is the product of modern web, where it was designed with security in mind. It was designed with attackers in mind, and the capabilities that we can and can't allow foreign code to run are forefront in the design of WebAssembly. Whereas the browser model originally wasn't run that way, and even with Docker, security is iffy at best. I mean,
you're trying to lock down things after the fact, right? Rather than just natively, the application gets to do nothing unless I explicitly said it could.
Yeah. Most Docker installations, most container installations aren't secure by default, and I'm not throwing shade at Kubernetes or Docker or anything. It's extremely difficult to make them
inherited from
really
Linux
secure.
security, right?
Yeah.
Like the programs could do everything out the gate, and all of that stuff is bolted on after the fact, even on native Linux. So it's not a container problem. It's just sort of all of these things were designed before anybody really thought about security.
Yeah. So one of the primary reasons for looking at something like WebAssembly on Kubernetes is the idea that we want that security by default. We want that sandbox. We want that environment. But we also want to take advantage of some of the other properties of WebAssembly, which include a very small binary, which technically isn't necessarily a binary all of the time, and the ability to start running while it's streaming. So based on your WebAssembly interpreter, some of them can start executing your application even before they finish downloading the rest of the application. So you've got a quicker start time and maybe even incremental different compilers, and then WebAssembly hosts that can run from your biggest Linux machine all the way down to the tiniest little microcontrollers using something like WASM 3. So single deployment that can cover all of the different architectures that we might want to play with.
And we can write it in any starting language. More and more compilers are being made to compile one language into WebAssembly. And then, as Brian will show off with WASP, we can swap out system calls under the hood and what is providing this stuff while the program is still executing, which is super powerful.
So we're going to run Krustlet, which is our kubelet implementation in Rust. So it's going to act like a Kubernetes node. And in that Krustlet instance, we have the capability of deploying two different types of WebAssembly modules. We've got WASI modules, W-A-S-I, and that is an emerging specification that allows WebAssembly to interact with its host system in a secure way. So WASI modules only have the capabilities that they are specifically granted by the host. The problem with WASI as of right now is that there's no networking available. So we can start a WASI module and it can execute and it can do things, but we can't really interact with it in a Kubernetes sort of way because there's no networking. So to overcome that limitation, we're going to use WASC, which is at wasc.dev if you're curious. WASC is WebAssembly Secure Capabilities, and it allows the host to make what seem like RPC calls into a WebAssembly runtime, an actor that runs in WebAssembly, and then the host actually takes care of the networking on behalf of that actor. So WASC is a really neat project. I've had a lot of fun working in WASC, and it allows us to create services, basically microservices. One of the most powerful parts of WASC outside of the security, which we'll get into a little bit later, is the ability for the operators, the people managing the system, to provide capabilities to the actors and then hot swap them as they're going. So you might have a logging provider. The actor will call, actor wants to log something, it says log hello world. And the host might log that to standard out, or it could log that to Logstash or something else. And we can, as the operators of the Kubernetes cluster, we can swap that out on the fly without the actor being interrupted, without having to restart anything. So it's a really powerful concept that allows you to manage your systems nicely. The actors don't care how it's being provided, they just consume those services. And we're going to take advantage of that provider concept, and we're going to create a provider for our WebAssembly actors for our robot. So we're going to create a robot communication controller provider. So let's start with just code. The Krustlet by default. Base is up here too. So I've got just a light fork of the Krustlet repository, which is at github.com/deaslabs/Krustlet. And the only thing I've done is add specific robot things here. So if you look at the Krustlet WASC code, it's going to, this is main basically, it's going to start up a WASC provider and then start operating as a kubelet and keep running. So main is really simple. The code that runs as a kubelet is under here. And these are just all the bits that respond to and query the Kubernetes API as needed to execute code. The important part that we want to check out is the WASC provider. And this is the provider that allows us to execute WebAssembly modules that conform to the WASC specification. So it's a WASM file that is signed and exposes an actor that will communicate with the host and do robot things. So let's take a look at our robot implementation. This is kind of fun. I'm going to go backwards on the robot implementation because I think it makes the most sense. We have a robot. It's connected to a, we'll be able to see that up in the corner. So it's connected to my laptop, the other table over there, by a serial port. And we want to be able to send messages to that using serial. So it's got a cute little interface. We connect it directly into the USB port of my Linux laptop. And we've got a Rust function called send that takes a phrase. And then I'm going to let Erik explain this from here because he wrote this connection. He's the master of all device things, so I'm going to let him talk about it.
So the robotic arms really are just, individual pieces chaining a series of servos together, and we just use pulse width modulation to control which position each servo is in. So there's sort of a serial communication here where we can talk to individual servos and tell them what position that they need to be in. And so all we're doing here is we're transposing these things, and then we have a lookup table for mapping positions that each of these things need to be in to get it to point at a given letter. I really wanted to do inverse kinematics with it, but that was way more math than I can do right now, and way more time. But if you're not familiar with what inverse kinematics are, that is giving, using an algorithm to determine an XYZ coordinate in space, and then using the measurements of these arms and servo, and basically calculating what the individual servo positions need to be in order for this to touch that place in 3D space. And that's what most like commercial robotic arms would use, say, in like an assembly line. You wouldn't, I suppose they might do a mapping, who knows? I mean, I've seen some pretty gnarly enterprise code.
Who knows? So this lookup table is kind of the heart of the code. It represents each of the 6 degrees of freedom that the robot arm has, starting at the base and then going all the way out to the pincher hand.
So the first one is this pincher hand, that 700 you see, that stays the same. Then that 634 is the rotation of that, and then we're just moving down the line here all the way to the one that's underneath here that rotates where it is. That's why you'll see the most movement in that, and because it's where it's rotating around the axis, or the base rather.
Yeah, so given a robot arm mounted in Mars, planted firmly on the ground, we can always know that the number 5, for example, represents these coordinates in the 6 different degrees of angles for that robot. So we're going to go and open the serial port, which is dev TTY USB 0. Notice I hard-coded that thing right in because this is the demo and not production. We will make sure that we can talk to the serial port and then throw an error if we can't. Then we'll open the port, and then Erik wrote a cute little ARM module called XARM. It's up on his GitHub.
Which I still need to revert, because you can program things like LED colors and all kinds of things, what the max positions in each direction can be. There's a lot you can program in these servos with commands. I still need to fully reverse engineer the protocol and implement more stuff into that. But for now, we're just trying to get Matt home.
That's all we care about. Yeah, we can clean up the code later. We just need to get Matt home. So the next thing we're going to do is we're going to create a hash map of the character values and then populate our lookup table with that hash map so that we can encode our characters and determine where to point the arm. Next, we'll encode the phrase that was sent to us by uppercasing it and then individually collecting the characters. And then for each character, we're going to call a touch letter routine, and touch letter moves the arm into the position that the letter is represented by in our little model. We added some sleeps in there so that it's clear what's going on instead of a big fluid movement.
It never stops at a digit. You'll never know what it's saying.
And then for the first transition, the first thing we did was lift the arm up straight so you could tell, this is where this communication starts. So that's the far end of this communication chain. We've got the host that's going to be talking over USB to our robot.
So now we need to take that and figure out how we inject that into our WASM runtime so that our WebAssembly code can call it.
Yeah, so we're gonna make a provider that gets run on the host, the Kubernetes host, the Krustlet host. And that provider will provide this capability to actors that run in WebAssembly so that any actor that has the signature to run this is able to do that. So let's go up to the top of this code and look at what a provider looks like. So this is a WebAssembly's WASC provider. And we have to import some of the WASC codec, which does all of the heavy lifting for talking in between the host and the WebAssembly module. But the real guts of the implementation are
A lot of
here.
this is boilerplate.
Yeah, much of it really is boilerplate. There isn't a lot of configuration that we need to do. There could be if I hadn't hard-coded the USB port, but I did. Get over it. But the real guts of this call are here under handle call. So the messaging that happens between the host, the provider, and the actor happen as RPC messages, basically. So we've got a handle call loop, and that loop runs continually matching messages that are sent from the WebAssembly module into this provider. And we handle, looks like 4 different messages here. We have the first one, which happens when the actor is instantiated by the runtime, so it's about ready to be run. And that creates a configuration, that runs a configuration system. Then we've got a message that gets called when the actor is about to be removed. And the important message for us is this transmit operation. So this one will take the body that's being sent as the message and send it off to the robot code that we just showed. So this is running on the host side in the Krustlet, and it's a capability that we're going to provide to WebAssembly actors. So let's go back and see how we wire this in.
Just for kind of terminology, actor is your application.
Yeah, it's your microservice, your app. Good.
Okay.
Thanks for pointing that out. All right, so let's go into our WASC provider. So this is the actual code that runs, that instantiates WebAssembly. This is the thing that's running on the host. If we were in a containerized Docker world, this is the bridge between Kubernetes and OCI. So this is like your container runtime interface bits. This is the thing that's going to start WebAssembly because we submitted a pod. So the Krustlet, sorry, I'm about to sneeze. So the Krustlet, when it starts, pulls its configuration from the Kubernetes configuration. Don't sneeze. Don't do it. There we go. All right. And then let's see here. To the good stuff. All right, we have a module store. So the implementation for our WASC provider creates a new WASC provider, which has a store of modules. We need to make sure we know what modules are running so we can capture the logs for each module and be able to map networking things. And then at the host level, we want to add capabilities to our runtime. Remember I mentioned earlier that WASC has capabilities. An actor can make all the capabilities calls it wants. If the host isn't running those capabilities, they will be ignored. Nothing will happen. And more importantly, if the actor isn't authorized to run those capabilities because it hasn't been signed using a key that is authorized to run those capabilities, then they will be ignored.
Which is another important security point about WASM, or at least through RASC anyway, is that it's not just a config file that says, hey, this thing can call this
Erik can do
syscall.
this.
Yeah, it has to be signed with a key.
Yeah, it's using real PKI, and the public key is embedded directly into the WebAssembly file with basically a JWT token that has the capabilities built in. You can decrypt that token and check it against your list of known actors and make sure that you trust that actor. If you don't even have to execute the WebAssembly. So there's a really nice security component here. So we're going to allow our host to be a robot provider, and the code to do that starts here. So we create a new robot provider, and we create a native capability from our robot provider. And then we add the native capability to the host, and that's pretty much it. Now the host has the ability to answer robot capability calls from an actor that's running.
So now we need to create our actor.
Now we need to create our actor. So when the Kubernetes API sends a message to our kubelet that says we want you to run this particular pod because the tolerations and taints match for our WebAssembly application, then it's going to call add, and this add will create a new WebAssembly runtime, WASC runtime, and that's using WASM time underneath with the WASC code on top for security and all of the kind of nice bits. And scroll through this. This is all pretty straightforward. The important part is down towards the bottom, where once we've loaded our WebAssembly and retrieved it from the container registry, which is another bit of magic that we'll talk about a little bit later, we have to instantiate the actor itself. So we retrieve the WebAssembly, we load it into the runtime, and now we're going to instantiate it. The HTTP run function here looks at the configuration from the Kubernetes configuration and finds out what ports we're going to run it, and then what capabilities that particular actor needs. And then right here, we create a hash map of environment variables that we're going to pass into the actor itself. And then we tell the actor that it has the capability to do robots and logging and HTTP. So once we've told the actor what it can do and allowed it to configure itself, then the actor gets instantiated and it starts running right down here. So once the actor is off and running, we've got an actor running as if it were a Kubernetes pod, and it's able to answer HTTP requests and send them back. Those can be exposed as Kubernetes services, which we are doing here, and it's running through the router in my closet out to the wide internet so that anybody can hack the robot if they're quick enough to see the address on the screen. Don't do that. So I've got a demonstration, the actor itself. So remember, all of this is just the plumbing to allow us to create an actor that will talk. So the plumbing is done. Now we need an actor, and our actor is the lightest bit of code here because WASC is such a well-written library. You really don't need a ton of code. Most of this is actually debug code because you wouldn't believe how hard it is to debug terminal serial port stuff on Linux in Kubernetes remotely. Unbelievable, especially when the debug statements don't show up in the host because they're actually in the WASM runtime.
Yeah, and so to clarify, this is written in Rust, but this is our WebAssembly that will be run. This will be compiled into WebAssembly.
Yeah, good point. So this doesn't have to be Rust. This could be any code that compiles into WebAssembly.
I suppose if you wanted to write WebAssembly by hand, you could.
You absolutely could, and you would get some really nice, concise WebAssembly without the extra cruft that some of the runtimes generate. So the WASC provider, the robot provider, had that operation transmit in uppercase, and in our message loop, if you have an operation transmit, we're going to do the thing that calls the robot. Here is the actor itself exposing that transmit function, and it's an HTTP handler, so it's going to accept an HTTP request, and it's going to return handler result, which is not really an HTTP response. It's more of a struct that will get turned into an HTTP response later. So we'll take the query string off of that request, and then we'll ask our host for the robot actor, robot capability, and then we're going to call the WASC robot transmit message function with the query string as its parameters. And then we pray. We hope that the host is going to get the message, and it's going to send it off to the robot.
How long was it for the communication to take place?
A 17-minute round trip or 17-minute one way, I don't know.
We're not. Hopefully ours doesn't take 17 minutes.
Yeah, they did the whole thing as this really nice montage in the movie, so I think it actually only took 3 minutes for this whole thing to happen. But it obviously struck a chord with us because we found it a fun way to demonstrate WebAssembly and WASC. All right, so we've got the actor here, and it's ready to go. It's going to receive a response back from the host, letting it know whether or not the call succeeded or failed, and then return a response back to the requester. And now we've got a actor. So in order to build that actor, I made a makefile because who can remember all of these fancy commands? So there's a lot of things going on in this makefile. I need to go through it slowly or I will lose myself, much less you. So let's start with, let's start again backwards and talk about keys. I mentioned that things in WebAssembly WASC are signed. It uses a tool called NK, which is a tool that the WebAssembly, the WASC team built to mimic or reuse the NATS key signing system. And so it creates two different types of keys, an account key and a module key. You can think of the account key like, your organization. Our DevRel organization would have an account key, and a module key represents this actor. So this actor has its own module key, and then there's an account key, and we're signing it with both of them. So the host can say, I trust anything that's run by this account, and it's okay for this actor to do these particular capabilities. So we're embedding those things into a token, and that is getting set into a text section, a comment section, basically, inside the WASM file. So the WebAssembly file has this security information embedded into it directly, including the length and the hash of the WebAssembly file itself. So you can't modify it without getting caught. So the first thing we need to do is make the keys if they don't exist. In a production type environment, those keys would already exist. I'm saving them in a key directory here, and then we'll use those when we're signing our WebAssembly after it's built. So after the keys are created, we need to build our WebAssembly thing. So we're just going to run cargo build. We're going to take this Rust code and turn it into a WebAssembly file. If you look at the cargo toml, the crate type is cdylib, which is going to give us WASC, and our target is what's the word? Our target is WASM32 unknown, which will give us the WebAssembly that we're looking for. So when we run make, it will build it with cargo, and then it's going to use WASCap, which is another utility that takes the keys that we've generated and our WebAssembly file as input, and it outputs the signed WebAssembly that has the specific capabilities that we've granted it embedded into the JWT token that's embedded into the WebAssembly.
Now we need to figure out how we're going to deploy that. Where do we stuff this so that Krustlet can get it? And that's where the creativity comes in.
That's the fun part. So there's a bit of code called WASM to OCI. This takes advantage of the
like the container registries. Some of them allow you to set new MIME types. So to kind of understand what a container really is it's a zip file with a manifest in it. And so we can take advantage of that and trick container registries to store and serve our WASM.
Yeah, so that's the ORIS project. There's a link here on the website that kind of describes that in much more detail. But if you look at the distribution registry, the Azure Container Registry, Google Container Registry, or Harbor from VMware, they all support these MIME types. And we're going to use WASM to OCI to take our WebAssembly file and push it to a container registry, and that container registry will store it. And that means that we don't have to do anything crazy in the Kubernetes world when we create our manifest.
We don't have to build our own service to store and serve these things and authenticate.
We're just going to give it what looks like a container name and store it in some container registry somewhere, and it's going to get pulled, and the end result will be that manifest and a WASM binary. So let's go back to our code and look at the piece that does that. That's over here in push. So it calls that WASM to OCI.
I'm still waiting for somebody to like stuff virtual machines or something crazy
it's coming.
in there.
It's going to
Store
VHDX
MP3s,
file.
serve MP3s out of.
That's not a bad idea, especially Docker registry. Oh, it doesn't work in Docker registry. Never mind. So in the WASM push, we're going to take the target WASM32 release of our Mars actor, and we're going to push it to the webassembly.azurecr.io container registry as the container called Mars WASC with a version that's defined up at the top of our makefile. I think it's at 0.5 right now. So after that's pushed, we end up with a container registry that's storing our WebAssembly for us. And now we're able to submit that to a running instance of Krustlet using a regular Kubernetes manifest. and there is nothing that is not related to Kubernetes in here. There's no extra bits about WebAssembly. The only thing that we've done is take advantage. If
that registry was not called WebAssembly, you would not know.
Yeah. The only thing we've done is take advantage of the tolerations and taints that are built already into the Kubernetes system, so that when our Krustlet runs, it has an architecture key that specifies WASM32 WASC.
Yeah, so if you're not familiar with both of these, a node selector basically attracts this workload to specific nodes that have these labels on them. And then the tolerations are because nodes implement the inverse of that, whereas a node can have a taint on it that says, unless you specifically tolerate this taint, you are not allowed to run on this node. So in this particular case, the Krustlet taints its node so that non-WebAssembly things don't end up being scheduled on it. So we have those tolerations in here to specifically tell the node, hey, we are WebAssembly. We know that that's the only thing you support.
We are WebAssembly. All right, so...
And apparently Manning is volunteering us for playing guitars after.
Oh, excellent. Here. Why don't you play while I deploy? Here you go. Be careful, that's my baby. All right, so we've done all the talking. I think it's absolutely time to do some rock and roll. Terrible, I know. Terrible. I'm sorry.
We need an amp. We need to turn it up to 11.
this WebAssembly goes up to 11. All right. So what I've got here is.
It needs to be tuned.
It does not need to be tuned. Liar. I've got our Krustlet code, and we're using just, which is a Rust make substitute. In fact, you can see the just file for this here. We're using this just file, and I'm calling just run WASC. So it's going to cargo run Krustlet WASC with some configuration here, node IP set and the node name set, and then the listening port. And that listening port is the port that it's running the Krustlet at. So we're going to do just run WASC, and this, actually, let's prove that we have Kubernetes cluster. First, I'm running microkates. Kube control, get nodes. So it's just got itself, Houston. I renamed my laptop Houston just for this. You're welcome. And then we'll do just run WASC. And that's going to start up our kubelet, our Krustlet. And if we pop over to another window, we can find out. So we've got our Krustlet WASC. I don't know, is that visible on the screen? Enter a couple times. So we've got Krustlet WASC as a node that's available. And if we get pods, we shouldn't really have anything running other than the standard core DNS bits. So there's nothing running in our system. Let's take a look at that deployment file, the marswasc.yaml that we were just looking at a moment ago. marswasc.yaml is going to pull the container that we built and deployed to the container registry, and it's going to give that to the Krustlet, which is then going to interpret that, pull the container down, grab the WebAssembly out, instantiate a WASC runtime, and give it that actor, wire up the capabilities, and start the actor running with an HTTP server that is specified in port 8080 here in our environment variables for the pod spec.
Our Svelte app will connect to that.
Yep, and then the Svelte app is wired to connect to my home network, and my home network is port forwarding port 18080 to the laptop, which is going to talk to the Kubernetes, which is going to talk to the robot, and there's a hole at the bottom of the seat. So let's try this. We need to do a kube control apply. By the way, that's kube control.
Is anybody ready to
come at me with your cuddles?
Quickly grab the URL and start saying
kube control apply -f mars. It's so anticlimactic. It just says pod mars created. Let's go back and look at the logs. So in here, it says WASC actor executing. All containers started for pod Mars, updating status, and get pod modified event for Mars and namespace kube system. Sounds like we have a pod. Let's ask Kubernetes if it thinks we have pods.
Because all of this, we've basically kind of implemented kubelet. All of the Kubernetes bits work. So Kubernetes thinks that this is a pod, even though it is not really a pod. It's WebAssembly running.
It's actually WebAssembly. In fact, we do a Docker PS. Wait, I don't even have Docker installed on this machine. So no containers were harmed in the building of this project. And let's see, we've got our pod running. We could even get logs for it. That's right, there's no logs yet. It hasn't done anything. So I think it's time to
send some messages.
I think it's time to send a message. Let's see what we can do.
Matt's been pretty lonely.
So what are we gonna send for our first message? Hi? Small?
Small.
So we can expect the letter H, I believe, translates into 48 for ASCII into hex. And then I don't remember, something like
45.
40 HI. Well, it's probably 49. HI, they're next to each other, HIJK.
Oh.
So we should see a 48 and a 49. It's going to moderate our message first. And we'll see whether or not Houston's moderators approve this crazy message. And let's move off to our robot. And we'll watch bated breath to see if that message ends up. All right, so it says it's transmitting. Oh, the robot arm is moving. It points at a 4. It points at an 8. Would even touch the 8? The little flag moved. Points at the 4 again. And points to
49.
9. Excellent. So the arm raises up to signal that we're done sending messages. So Matt can take his ASCII to hex calculator out and say, they just said hi. How exciting. All right, so let's send another message. Actually, let's go back and look at the logs and see what we got going on in the logs. In our logs, we clearly have some debug out coming from code that I wrote. You can tell it's code that I wrote because it's just random stuff dumped to standard out. And we've got the 4.8 and 4.9, so those are the two sets of hex characters that are being sent to the robot. And I think we should send another message. How about pick you up tomorrow? Pick up tomorrow. So it's going to send all that hex.
We should have dropped the link so other people can send stuff. Can you drop me on Slack or something? What do you have? Gosh. Link incoming.
Be gentle or we're shutting it off.
All right, anybody who stuck around to the end gets to play. So if you open that up and send messages, it will control the robot arm.
And really, don't try to evade our content moderation system. It's very simple. And we're going to be sad. Probably Eric's going to get fired if somebody drops F-bombs.
Of course, it's going to be me.
Well, yeah, it can't be me. So if somebody's going to get in trouble, it has to be Erik. So we can see our robot getting messages. Let's take a look at the logs, which you can't see, but I can. There's a lot of hex coming across the screen. Thank you, everybody, for sending your messages. Those will get sent as they come through.
And so I think we have a couple minutes left, and somebody in chat mentioned that it's kind of intimidating looking at all of these components. So maybe we could take a couple of minutes to just point out, if you wanted to build something and basically run WebAssembly on Krustlet, what do you need to know? Right, so assuming you've installed Krustlet, we just have to look at the parts where we have the bits written in Rust. Yep. You would need to write that, compile that, and sign it, assuming you were using WASC.
The actor.
Right.
And really 2/3 of the code that we have here, you wouldn't need to do if you were doing microservices. We had to build an extra capability for the Rust talking to the serial port so that we could talk to the
all you really need to do is write it in whatever language to compile to WASM.
Yep.
You would need to do the WASM to OCI so that you could push it up to a registry.
But that's built. I mean, it's just adding a line to a makefile, so that's not bad.
And then assuming that you didn't need any new capabilities introduced to your program that don't already exist in the system, that would be it. So some of the other bits that we walk through are really because we wanted to introduce the ability for our WASM program to control this robotic arm, which isn't really a capability that exists inside the WASM runtime or on the host that we could just inject in and sign that capability. So we were kind of showing a few things there where we were kind of building a new capability as well as writing our app.
Yeah. So if you're just going to build an actor,
that thing is just going crazy.
It's going nuts. You can look at the tutorial on wasc.dev. The project itself is the tiniest amount of code. We're talking about just a handful of lines outside of our definitions that return hello world. So an actor that does very little in terms of an HTTP response is just a handful of lines of code, and the intimidation factor is pretty low there.
Right. Yeah, we kind of went from the bottom up explaining how all of it works under the hood, but it's similar to, you know, the difference if you're in the Kubernetes world, the difference between writing an application and designing an architecture that's going to run on Kubernetes sort of requires a different set of knowledge and skill set than operating a Kubernetes cluster.
All right, so we're kind of running out of time. I did want to pop up the more information slide on the screen because there's a handful of links here where you can get more information. aka.ms/krustlet-rust. That's the introductory blog post about Krustlet. The code itself is on GitHub at github.com/deuslabs/Krustlet. We love new contributors. Many of us on the Krustlet project learned Rust while we were taking on
still learning
projects.
Rust.
Learning Rust. Learned is such a strong word. I haven't learned anything, but I'm learning Rust as I go, and I've had a ton of fun. Lots of really patient people in the project, Taylor Thomas and folks that are just amazing in terms of helping people get their Rust skills up to speed, learn about WebAssembly. So please come join us in the Krustlet repo, learning a lot there. If you want to do Azure Static Web Apps, you can go to aka.ms/ASWA. And then learning about WASC is wasc.dev. Then finally, you can reach Erik and I through the usual channels. Twitter at bketelsen for me, Twitch bketelsen, Twitter at Erik St.Martin, and Twitch erik.dev. So we'd love it if you reached out and asked us any questions about WebAssembly or Krustlet or how much fun we have working at Microsoft. My wife this morning, she's like, I don't even understand how you get paid to do this crap. How do you get paid for this?
I just spent a couple weeks working with somebody at work building an intelligent video security or surveillance system that does object detection and counts people and cars and cameras and stuff. And it's like, this is work?
Yeah, we have it so rough. So thank you very much for joining us today. And that's all we have.
Yeah. And we'll hang out on the Twitch and Discord. Probably let's move to Discord so we don't interrupt the next show, but we'll be on Discord to answer questions.
Awesome. Thanks, everybody.
Rancher is the market leader in open source cloud native Kubernetes management and allows you to manage and scale workloads consistently across thousands of clusters in any environment, and support any certified Kubernetes distribution. Monitor the health of all your clusters through a single pane of glass. Simplify and automate the deployment and management of containerized applications. Deploy persistent storage with just one click. And simplify global access control and security policies for your entire Kubernetes environment. And because Rancher is 100% open source, you can achieve all of this at a fraction of the cost of legacy solutions. Kubernetes is the key to unlocking digital transformation. Rancher is the key to unlocking the full potential of Kubernetes. Schedule your free no-obligation consultation today.
With CodeFresh, we've rethought the CI/CD build and release process from the ground up for the world of microservices. As you adopt microservices, the number of pipelines you need to create and maintain skyrockets. Old build systems can't scale to meet the demand. But CodeFresh allows you to standardize your steps and package them in Docker images, then reuse them across multiple pipelines. You can think of them like a library of building blocks to build images, perform canary releases to Kubernetes, launch serverless functions, do security scans, UI tests, and so much more. And since the steps are Docker images, you can very easily create and use your own private steps or use images contributed by the growing CodeFresh community. Traditionally, the CI/CD experience has been pretty unfriendly, but we built CodeFresh to be a tool we actually want to use with a beautiful and functional UI throughout. In CodeFresh, you not only see pipelines and builds, but you also connect directly to your runtime environment and see what services you've deployed, and you can trace them back to the code and configuration changes, as well as seeing who worked on them and how they were validated. CodeFresh has an embedded Docker registry and Helm repository with integrations to all your external registries, so it's easy to manage and promote images and charts. When teams adopt CodeFresh, they release more often, and their engineers have more time to build their product, rather than building pipelines. That's why enterprises and startups alike love CodeFresh. Go to codefresh.io to create an account so you can start building your own pipelines, or schedule a one-on-one with one of our CI/CD experts to help you get up and running quickly.
Hi everyone, I'm Naomi Ceder, and I've been asked to talk a little bit about the upcoming Manning Python conference on Twitch. So Manning has been one of the leaders, I think, in using Twitch to connect users and people interested in coding during the COVID-19 crisis. And I guess it's just logical then that they're having a series of conferences on Twitch as well. I think to give all of us who are missing the ability to go to conferences in person at least a little bit of a taste of conferences again. So I hope you can join us. The Manning Python conference is going to be here, same place, twitch.tv/Manning Publications. And it's going to be on July 14th. We're going to have 4 sessions, and I want to tell you a little bit about what we have going on. They're going to be 60-minute sessions with some time afterwards to have questions. And just for the heck of it, I thought I'd do them in reverse order for a change. So we're going to have a session, Fundamental Search Algorithms for Maze Solving by Dave Kopek. Dave is the author of Classic Computer Science Problems in Python from Manning, which has been very popular. I had a chance to catch one of his live streams on Manning's Twitch channel earlier, and I'm sure that this is going to be an interesting session delving into search algorithms and how they apply to maze solving. It's kind of an interesting area, I think. We're also going to have a live cast of the Python Bytes podcast by Michael Kennedy. Python Bytes has become one of the standard podcasts in the Python community. People look at it to a little bit about what's going on with people involved in developing Python and the Python community generally. I'm not sure that the entire format for this particular episode has been mapped out yet, but I am sure it's going to be interesting both in terms of Python and the Python community. So I'm looking forward to that one. We're also going to have a session from Reuven Lerner on generators and coroutines, creating in-program nanoservices. Reuven is the author of the Python Workout, which is a Manning book that is in MEEP, is still in development. And if you happen to catch the PythonCon 2020 video of Reuven's talk on digging into functions, that was fascinating stuff. And I'm certain that when he starts talking about generators and coroutines, that's going to be a very, very interesting talk as well. And then I will be kicking off the day, actually, with my talk. It really is easier to ask for forgiveness than permission. And this talk will be about exceptions and how Python uses exceptions to handle situations and sometimes even for flow control in ways that other languages, like, for example, classic example, Java, do not. Java is very much what we call a look before you leap language, where type checking and various error checking things might happen in advance. Python is an easier to ask for forgiveness than permission language, where things are tried, and then if there's an error, we count on throwing an exception and handling that exception. So this difference has kind of led to a lot of people having maybe some misconceptions about how exceptions work in Python. So I kind of want to dig through this and maybe from the inside out sort of figure out what's going on with exceptions and how they really work and what's really going on there. This will be kind of similar to the Exploring Python streams that I've been doing on Twitch on my channel, where I try to look into sort of fundamental Python concepts, and by doing experiments and poking around at them, sort of look into how they actually work. And you know, speaking of that, I'm also in the very beginning stages of developing a live project for Manning that will be the same thing in terms of exploring the fundamentals of Python. So that should be, I hope, interesting for everyone, particularly if you don't really have a good grip on how Python does exceptions. And I think it will be an interesting day all around. I certainly hope that everybody can join us. Again, it's going to be July 14th, twitch.tv/Manning Publications, a day of Python brought to you by Manning Publications. I'm looking forward to this conference, and I really hope that a lot of you join me. Thanks. See you there. Bye-bye.
All right. Hello, everyone. Sorry, I've been told that I'm live. Excellent. All right. What I think I'm like the last speaker and second to last talk going on at this conference. Thank you so much for having me. To all the Manning organizers. So I'm going to be talking about troubleshooting guides and team docs for your Kubernetes deployments using notebooks. Now, this talk is probably going to be a little bit different than a lot of the other talks you've seen before, but hopefully you'll find it interesting. Honestly, the title of this talk is so ridiculous and full of buzzwords that I feel inclined to add like on the blockchain to the end of it, just to add more to it. But just so we're clear, I'm kidding. This is not a blockchain talk. However, what this talk is about is less about a deep dive into what I'm about to show you, but more to kind of spark interest in you. The idea here is that you take what I'm about to show you, take it back to your project or to your company or whatnot, and see kind of how you can adapt it for your workflow. And that's going to basically be the main takeaway for today. And if you want to follow along, go ahead and go to this link. This is where we're going to start this talk, and we'll get there soon enough. I just got a few slides that I want to get to. But yes, github.com/Tyler Leonhardt/Manning Kubernetes Notebooks is all of the material for this talk. And also a place where you can interactively work alongside of me. I should probably introduce myself. I haven't said it yet. My name is Tyler. I'm a software engineer at Microsoft, and I work on the PowerShell team at Microsoft. If you want, you can follow me on Twitter at Tyler Leonhardt. You can also follow me on Twitch, where I also do a bunch of live coding. You might have mentioned that this is sponsored by the Live Coders, and I'm actually one of the members there. I don't know if you can see my jersey here, but this is a Live Coders jersey. I love this thing. It's great. Anyway, like I said, I'm a dev on the PowerShell team, and I'm also currently writing the book, Learn PowerShell in a Month of Lunches. It used to be called the Linux and macOS edition, if you've seen it before, but now we've shifted a little bit, and it's going to cover Windows, Linux, and macOS in definitely a more high-def image than what is seen here, I assure you. And so you might be wondering, and I'm sure at least one person in the audience is wondering, like, who is this guy? This PowerShell person? This is a Kubernetes talk. Kubernetes conference. Why are you here? And it's a good question because, frankly, I'm not a Kubernetes expert. Like, I work on a product at Microsoft, and so my team specifically doesn't have a whole lot of services and are not doing much with Kubernetes. But I like to think that I know a thing or two about docs and running commands, being on the PowerShell team. So what I'm going to do next is I'd like to ask this audience that I can't really get feedback back from, if you align with this, if this is your team. So my first question is, does your team have possibly miscellaneous onboarding docs for your project? In other words, steps on how to get a local build working, or steps for setting up your environment locally. Or perhaps your team has a bunch of troubleshooting guides for when stuff goes wrong. Stuff like, like honestly anything, right? Anything that entails some sort of steps that involve running a bunch of commands to get back diagnostics and things like that. And maybe those docs are in like OneNote or Notion, Google Docs, or maybe they're in plain Markdown. So this talk is basically saying that you could do better than that. Let's go ahead and take a look at those options that I just mentioned. So I can definitely say with firsthand experience using OneNote, because tons of teams here at Microsoft use OneNote, unsurprisingly. And it's a really good product, don't get me wrong. But using it for like onboarding documentation has always been kind of tricky because number one, it's not source control in the sense that you're using like a Git repo with your OneNote doc. So change tracking can be kind of hard. In practice, what this usually is here are the steps to get started. And then like all of those steps will be crossed out. And then there'll be a new box next to it that says, here are the new steps to get started. Maybe this resonates with you a little bit. And also like code formatting can be a little tricky in some of these apps. I think they're doing fine with it, but it's stuff like using the wrong quotation marks when you copy and paste commands into your terminal, things like that, right? And then Markdown is in my opinion, much better than the other options because it can sit right next to your code in a Git repository or something like that. But one thing that is kind of annoying is that it requires an extra step to render it, which might be just like opening it on your GitHub repo where GitHub will automatically format all of it or render it, or using VS Code to like render the Markdown that you're looking at. And so Markdown is definitely better in that sense, in my opinion. But all of these have the same problem. They're all static. If there are any commands that you have to run in your terminal, you have to copy and paste them into your terminal, which is kind of annoying, especially because, we're We're humans, and sometimes we're not good at copy and pasting. We paste the wrong thing or run the wrong command, something along those lines. So next I want to paint is a picture of this. And I promise this won't be, there won't be too many more slides. We'll get into some demos to see what the heck I'm talking about. But picture this. Markdown, but the code blocks within Markdown are executable. You can run them and see the output. But in addition to that, they're also backed by a JSON file or something at least readable to the human eye and can be stored in a source control environment like Git. If that sounds appealing to you in any way, and you don't know what I'm talking about already, what I'm talking about is a concept called notebooks. Notebooks are this concept of mixing Markdown documentation with executable code and see the output of said executable code. So notebooks are not really a new concept by any means. In fact, data professionals, data scientists have been using notebooks for years. And why? Well, number one, the interactive experience came first. It's fantastic. You have different blocks of code. You hit the play button and you see the output right below. Run code, see the output. It's very, very straightforward. And also it enabled additional richer capabilities like plotting, as you can see in the screenshot. There are graphs and things like that, which is another thing that's very important for data scientists. And so my team on the PowerShell team, we kind of thought about this. We're like, hang on a second. Run code, see the output. Well, that sounds very familiar. Yeah, that's right. It's exactly what a terminal does. You run code, you see the output. And so then we thought, all right, well, we do so much work in our terminal, and especially in the Kubernetes ecosystem, thanks to kube control. What if we applied all the greatness of the terminal into this notebook experience? And since we're at a Kubernetes conference, focus it on running kube control commands and that sort of thing. And so that's what this talk is about. A very like exploration type talk. And my hope is that you'll find some of this interesting. So I should give a little bit more context. I have one more slide, and then I'll actually show you what I'm talking about. And I need to talk a little bit about the architecture. So the way that we're going to get this to work, this Jupyter or this notebook experience to work for running arbitrary kube control commands, is we're going to use a product called .NET Interactive. Now, don't get scared if you're not a .NET user or get kind of wary when the phrase .NET pops up. We're going to leverage it in a little bit differently, as maybe it was intended to be leveraged. So .NET Interactive is going to be our backend. So that idea of executable code, well, that code has to be executed somewhere. And so in the notebook experience, there's this concept of a kernel. And one of the popular notebook experiences is a product called Jupyter. And a kernel is not, it doesn't have anything to do with an OS kernel, like a Linux kernel or anything like that. It just means the runtime of your notebook. And so in our case, what we're going to use is we're going to use .NET Interactive as our kernel because it provides PowerShell support out of the box. And it's cross-platform. So you don't have to install anything else besides getting .NET Interactive up and running. You don't even have to install PowerShell on the machine. The .NET Interactive already comes with it. Also, PowerShell can already run native executables just like Bash and Z Shell can. So running kube control, that's a no-brainer. And one additional thing that I think is kind of fun in all of this is that .NET Interactive already provides plotting out of the box for PowerShell. So now we can think about, hey, what happened? What kind of unique scenarios do we have for running kube control commands and then plotting them on a graph, plotting those results on some sort of graph, what that would look like. Okay, that's enough slides for now. Let's go into a demo, and you'll see what the heck I'm talking about. All right. So if you had gone to that URL, and I'm just going to get the, there we go. I'm just going to get the chat here so I can kind of skim through that. If you had gone to that URL in the slide, you're brought here. And there's a couple things I want to point out. First of all, I want everybody to go ahead and hit this little button here, launch Binder. And what this is going to do is, so Binder, also known as My Binder, is this free service that'll spin up a container. As you can see, it's spinning up a container here. Spin up a container on in the cloud somewhere and give you a complete notebook experience right in your browser without having to install anything. So go ahead and get that going. It might take a little bit of time to build, but the images are cached. So you know, the first time might be a little longer, but the next time should be faster. But anyway, while that's running, I'm going to talk about a little bit about this repo, the way I've laid it out. So I think the important thing is the Docker file, which is what that is building currently. And one of the things that I did here is that I installed all the stuff needed for .NET Interactive to work. I installed .NET Interactive here. And I also installed kube control in the container as well, so we had access to that. And also did a little bit of setup so that completions for kube control work within PowerShell as well. And feel free to kind of skim this and judge me on my Docker file crafting if you'd like. But this repo gives you everything to run a full notebooks environment, both in your browser via MyBinder. Gosh, I should have spun this up beforehand, but that's okay. It's almost done. And also by just running the Docker file locally with some steps here. So this was actually generated from a template that I had made, a GitHub template that you could use if you'd like. And it basically comes with the same Docker file and all these good stuff. There's a notebooks folder in here. You just dump your notebooks in here, and then those will readily be available within Binder or locally. The other thing that you could do is you could clone this repo, clone my talk repo, and then open it in either Azure Data Studio, Interact, or VS Code are a few programs that I'll talk about a little bit later. And this is definitely taking longer than I was anticipating. Naturally, of course, when I was running through this talk, it took maybe a fraction of this time. But hey, we're doing it live, folks. That's what this is all about. I just saw in chat that someone said Netflix deploys notebooks to prod, and that's 100% true. They have a huge dependency on notebooks. It's incredible. I haven't looked into the specifics of what they use notebooks for, but they do a ton of stuff with it. All right, it's pushing the image. It should be ready in just a sec. In the meantime, how are you all doing? Has the conference been good so far? I haven't I'll be honest, I haven't watched any of the talks because I get kind of nervous when I'm about to speak. So I just kind of take my mind off of things. But I'm going to go back and watch them for sure. I hope you've enjoyed the conference so far. We're getting there. Oh, yeah, sorry, my bad. It looks like someone beat me to it. Yeah, so I think it says it in the README. You see it comes with something called Jupyter Lab, which is a very well-known way of running notebooks, and also .NET Interactive, which will be our runtime, our kernel, so to speak, PowerShell itself. I talked about Unix completers, which is how you get kube control completions working in PowerShell, and then kube control itself. And also, it sets the theme to dark mode because I happen to like dark mode personally. All right, it's starting. We're almost there. Yes, all you need to do is click on that little launch binder thing, and then you'll get exactly what I'm going to show you. Launching server. Drum roll, please. I hope that if any of you are nearby me here in Seattle, that that you'll pull from my cached image here, and it'll be much faster for you. We're almost there. Almost there. What's that say? Is Binder a multi-user? I've opened it. It shows Jupyter Lab. No, it's one container per user. Hey, there we go. Wow. Well, that took much longer than expected, but we're back on track here. So let me just go through a few things by creating a new PowerShell notebook here. So as soon as I create a new one, I get this untitled.ipynb file, which is a Jupyter notebook. And so, I talked about mixing Markdown and code. So you can see in this dropdown that we can choose code or Markdown for this particular block. Hello, Manning Twitch fam. This is bold. And then I'll do Shift Enter, and it renders that. Just to prove to you that we also get the executable code, let me go ahead and do uname-a. And what we'll see is we are indeed running on Linux, which, I mean, I'm running this talk from a Mac, so not the same thing, right? Something a little more PowerShell-y. Let's just do, I just did PSV and hit tab, which gives me PS version table. So that'll show what version of PowerShell we're using, which is PowerShell 7, which is the latest major version of PowerShell. And then just to prove to you that we do have kube control here, I can do kube control, space, tab, and then we see all the different options here. And we'll do version, Shift Enter, and we see our client version. And also, I mean, we're not connected to any server at the moment. This container just has kube control, but proof that kube control is there. So I wanted to give you a little look of the behind the scenes of what this file looks like. So IPYNB, that's a Jupyter notebook specifically. There are different flavors of notebooks. We'll get into that later. But this is a Jupyter notebook. And so I can right click on it and do open with editor, which gives me a regular text editor as well. And you can see that it's just JSON behind the scenes. And I think what's interesting in this is that number one, we can see, all right, cell type is Markdown, and here's the source. Cell type is code. this is the output. So here is what we're seeing, and then also the, where is it? Okay, sources is uname dash a, and text, we saw that text show up. So you could see like all of it's there, right? All of what we saw right here is in that file, which means that in theory, you could have a GitHub repo where you check in the results, the expected results of some troubleshooting guide, troubleshooting notebook. And so then when someone clones that repository and goes to try to run through that notebook, just like whoever did before them, they can compare and contrast their output versus the expected output. And so that is one way to kind of show where a troubleshooting scenario might come in handy. So I wanted to show you this just so you can get a feel for the user experience. And this program is called Jupyter Lab, which is like the latest offering of Jupyter Notebooks. There's something called Jupyter Notebook, which is a little bit it's something different than Jupyter Lab, but Jupyter Lab is their like latest and greatest thing. You can go to like Project Jupyter or something, Jupyter.org, I think. I should have gotten this beforehand. Anyway, search for Project Jupyter on your favorite search engine. You'll find it. Anyway, that is a quick little taste of notebooks. I'm going to go back to my slides for a second just to talk a little bit about the state of notebooks, and then we're going to go into 4 other demos, all of which have something to do with Kubernetes, I promise. So I briefly mentioned it, but notebooks are an abstract concept. When I'm talking about notebooks, I'm talking about the user experience where you have markdown as documentation and code that you can execute. Now, behind the scenes of a Jupyter notebook, it's a JSON file, but there are other types of notebooks out in the wild. And I'm going to talk about another one in a sec. But so the comparison is Jupyter Notebooks. Their file extension is IPYNB. Their file format is JSON. And the file contains the output of the last run of any executable part of the notebook. Now, the other type of notebook that I want to introduce is something called the .NET Interactive Book, or otherwise known as a DIB file. File extension is DIB. The file format is something called scriptwich, which is a working title, don't worry. And the file does not contain the last output. So the reason why this exists is that the .NET Interactive team is attempting to try to take notebooks as a concept and make them more automated. And so the idea is that you have this very easy to read file format that says, in PowerShell, run this code. In C# run this code. In F# run this code. And then from there, .NET Interactive, some executable, would then be able to run that in an automated fashion. So that's why this exists. And there's going to be a lot more to this. It's very early days for these, but we are going to look at them today because they provide the fastest way locally to get started with a PowerShell notebook experience. So now we've got to choose your own adventure. And the reason why this is as complicated as it is because the state of notebooks is so new compared to like, well, basically any other like programming paradigm that we're all still kind of like figuring out the best way to leverage these. And of course, they're great interactively, but a lot of folks are saying, all right, how do we make them automated? And how do we like balance both the nice interactive experience locally and say a cloud experience versus like an automated experience. So I've broken it down like this. Let's look at the left side, the cloud part. So for now, there's only a way to run IPYMB files, so Jupyter Notebooks. The best way to do that is in Jupyter Lab. And today, you can do that on either my binder, or you could self-host it somewhere else. Kind of like I showed you the Docker file, you could go and throw that into whatever you want to throw it into. The reason why I'm not mentioning something like, some of you might have heard about like Azure Notebooks or Google Colab, or I'm pretty sure there's an AWS one that I can't think of, but I'm sure there is. These are other hosted environments for notebooks, but they usually support like Python and then like Julia and R. So they're more catered towards the data scientists folk. Eventually, as this gains more traction, you'll see adoption there as well. But for now, these are the offerings. And I think between my binder and a Docker container that you can run anywhere, your possibilities are pretty high from the get-go. Now on the local side, things get a little bit more fragmented. If you want to actually run Jupyter Notebooks locally, you absolutely can. Jupyter Lab is just an executable. You can go and get Jupyter Lab and get started with it, just as you saw in my browser from my binder. And I often do that because I actually kind of like the experience of Jupyter Lab. There's also another product called Interact, which I'm actually not sure if it uses Jupyter, but it reuses the same IPYMB format. I haven't looked too deep into it, but I know it exists, so I wanted to mention it here. The other one I want to focus on is Azure Data Studio. Azure Data Studio, I should be explicit and say that it is not an Azure service. It's an actual executable that you download and is actually a fork of Visual Studio Code. And so you'll see the side-by-side comparisons because I have both. You'll see what I'm talking about. So Azure Data Studio provides a way to run Jupyter Notebooks inside of a VS Code-like experience. And that's why I have it listed here, because if you are familiar with VS Code and you want to run IPYMB files, then Azure Data Studio, I think, is one of the better ways to do that. In the future, Visual Studio Code itself will be supported for IPYMB files, but it's not quite there yet. The Python extension for VS Code already offers a Jupyter Notebook experience, but much like Azure Notebooks and others, it only supports Python because it's the Python extension. I think it might also support one or two other languages, but more that data science route. However, the .NET Interactive team is working on providing a VS Code extension that will work for IPYMB files. It's in the future. It's coming. All right. And so then the last thing all the way on the right is the DIBs. And DIBs and VS Code are probably the simplest way to get started with all of this, because everything to the left, the IPYMBs, those have like a dependency on Python, for example, because Jupyter, the runtime itself, uses Python. And so if you happen to be on Windows, for example, I know Python can be kind of annoying to install and to manage. And so the DIBs route is a completely Pythonless installation. In fact, all you have to do is install VS Code, the insider build, and the .NET Interactive Notebooks extension for VS Code. And so with that said and broken down, I have 4 demos that I'm going to be talking about now. And here they are. So we've got managing a local Kubernetes cluster, managing an AKS cluster locally, managing an AKS cluster using AZ Shell. We'll talk about what that is later. That's Cloud Shell. And then plotting output of kube control. So I have 2 DIBs and 2 IPYMBs that we'll look at. All right. So first, the side-by-side. On the right is VS Code. On the left is Azure Data Studio. They look pretty similar, don't they? We're going to start with VS Code. So one of the things that I did, because I mentioned I'm not a Kubernetes expert by any way, shape, or form, but what I did do when I was making this is I looked out in the wild for existing troubleshooting docs for Kubernetes. And one of the things that I found was this from the Kubernetes.io website, application introspection and debugging. And so I was scrolling through it. I'm like, okay, this looks interesting. And then I was like, wait a minute. Kube control command, output of said kube control command, output of said kube control command. Does this look familiar at all? When I saw this, I'm like, this is perfect. I'm going to turn this doc into a notebook, and we're going to be able to like actually walk through it rather than it being static as you see on this page. So let me go back to VS Code and we'll take a look at what that looks like. All right. So like I say here in the prereqs, by the way, if you clone this, open it up in VS Code, make sure you get the insider version of VS Code. It's important because this this notebook UI is still only in insiders. And then you go to the extension marketplace and you search for .NET Interactive Notebooks and you hit the install button on that. Then you'll be good to go. And then in my repo, I have a couple of dibs that you can open and follow along with me. So, all right. I could have sworn there used to be a command here, but that's fine. Oh, there it is. Okay. Like I said, it's still in insiders. Anyway, so the prereqs for this, Visual Studio Code Insiders, .NET Interactive Notebooks. Again, like if I double click on this, it's just Markdown, right, behind the scenes. So I've got links, I got headers, all that stuff. So I have the little check mark to bring that back to the rendered look. So this particular notebook is using this this module called PowerShell YAML, and this idea is you can take YAML and turn it into an object that PowerShell can interact with. So PowerShell is an object-oriented shell. It has access to all of .NET because it runs on top of .NET. And so when you pipe commands, PowerShell commands, you're actually piping objects rather than just text. You can still pipe text, but you can also pipe objects. So this, you'll see where this is used. It's definitely an optional installation when using PowerShell and Kubernetes stuff. But I wanted to install it to show you what it's capable of doing. All right. So like I said, the rest of the article comes straight from this Markdown file, and all we'll be doing is just hitting the play button a few times. So here's the very simple deployment that is available that we're going to run. And so let me just go ahead and execute the cell here. Now this is operating on my local instance of Kubernetes running in Docker for Mac. And so cool, we've done our deployment, and let's go ahead and check our pods here. Hit the play button. There we go, we've got some pods. So we can obviously look at kube control describe to get some more information. What I'm doing here is I'm just getting the pod names. I want something that you can do within PowerShell is you can pipe that JSON output that kube control provides right into something called convert from JSON, and then from there you can use that variable like it's an object, like you would in any other language, in like an object-oriented language like this. So I'm just like drilling down into that object that comes back. And of course, like I could have done something like this. Maybe that's kind of hard to read. Let me get rid of this. I could have done something like this, but in a world where I don't know what I'm looking for, sometimes it's really nice to just go through it this way. And of course, tab completion is readily available for you once you run this line of code. You run this, and then you can do $results dot and then hit tab, and then it'll show you all the options and all that. In fact, why don't I just do that? So I'll run that piece. And then if I do like $result dot items, it's an array. So let's get the first one. Dot metadata. Excellent. Dot stuff. You get the idea. So in case you don't know what you're looking for, you have a way to get to that. Right. So clearly you could see that I've run my my kube control describe pod for that particular pod that I cared about. And all this did was it just got the first pod name that it could find, just so that this would be more interactive. And so then there's a lot of text here from the original troubleshooting guide. Feel free to read it if you'd like. But I'm just gonna kind of skim past it. It's just giving some details on what is the output of describe, and then an example of troubleshooting here. So debugging when there are pending pods. So in order to like replicate pending pods, what I've done here is I've taken that original YAML that we used previously. I'm going to convert it from YAML, similar to convert from JSON, and then I'm just gonna start messing with some of the properties. Change replicas to 5, up the CPU limit to 2000, just to like force it to run out of resources. And so then I can run that. So that's the only usage of the PowerShell YAML module. You can see how it's not necessarily needed, but it was useful for this example. So cool, I've got my deployment set here. And let me go ahead and get my pods now. So we see one is terminating, but we do see a couple are pending here while the others are running. And we can just keep running it if we'd like. And it doesn't seem like anything is changing. It still says pending. That's a problem, obviously. And so now we can go ahead and, grab that pod that's pending. Grab the first one that's pending, as we do here with the field selector, and then describe that pod to see what's going wrong. I kind of like doing talks with notebooks because I get to actually still run code in front of you, but I don't have to like concern myself by accidentally typing the wrong character and then my script doesn't work. It's a nice interactive way to show you all what this is possible, what this can do. Right. So events, we've got insufficient CPU here, and of course we can also run get events with failed scheduling to see that we still have insufficient CPU. We can get it that way as well. So what else is here? This is just saying that you could specify a namespace if you'd like, and that you could also output YAML if you so choose. And of course, you could use PowerShell YAML to pipe that into convert from YAML, and then you'd have an object that you can run with. But there's the YAML as well. So cool. That's pretty much the end. The rest of the doc goes into like spinning up multiple nodes, and there's just like a ton of extra stuff that it does. But if you want to check out another example, this repo that you see here is actually what gave me the idea to make the template repo, which gave me the idea to make the like notes for this talk off of. So that is this first example. I hope that you could see kind of the power of this notebook format for troubleshooting docs. So now I'm going to switch over to Azure Data Studio. And I want to try showing you this other feature within .NET Interactive, within the PowerShell supported .NET Interactive, called Enter AZ Shell. So cool. I'm in the getting started. I'm going to run this command, enter AZ Shell. And what this is going to do is it's going to give me my device login here. So let me go over here. Cool, cool, cool. Copy this. Boop, boop. It's totally interactive. Like this cell is technically still running, as you could see. And I was able to interact using this device login. And now it's connecting to a Cloud Shell instance. Now, if you're not familiar with Azure Cloud Shell, if you go into the Azure portal and you see a little like shell button at the top, that gives you a Cloud Shell. It's literally just a shell in your browser that has a bunch of stuff already installed in it. But most importantly, which I think is the most powerful part of it, is that you're already authenticated to Azure within Cloud Shell. And so you don't need to log in anymore. So I've already authenticated here. So now I can interact with all of my Azure resources right from this notebook. So in case you doubt me, let me go ahead and run these. And we see we got Linux. We're running on Linux. I'm on a Mac, so clearly different. And then we have 2 kubectl versions. And it actually saved my server connection since the last time I used Cloud Shell. I forgot to clear that connection, but oh well. Anyway, I don't know if you know this, but if you use AKS, there's a PowerShell module to use. There's a PowerShell module for managing AKS, and these are all the commands that come into it. And if you want, you can take one of these and then run get help like that. And here, I'll comment this one out and then we'll run that. And that'll give you a bunch of information on what you can run. But so my subscription should already be set, but I'm going to run that anyway. And let me go ahead and do this. So I'm going to get all my get all of my AKS clusters, and we see that I have one. Manning test AKS. Cool. So now let me go ahead and this is another command available by AZAKS. And what this does is it basically says to kubectl, hey, I want to use this AKS cluster as my server. And so then from there, of course, I had already had it working, but now you see that there's a server version there because I ran this command previously. And so then we're hooked up to or we're connected to a server, to an API server, an AKS cluster specifically, so I can go ahead and apply my Nginx with request YAML and get those pods, and we're good. And so now I'm like managing this AKS cluster all from within a Cloud Shell environment, already authenticated, and I don't really have to do much. And then when I want to exit that Cloud Shell session, I just hit exit. And so now, remember, docs are just markdown. Here's a link that links me to another notebook in this same folder, which is awesome because then I get to move on to the next thing. So let me go ahead and redo this really quick since I'm logging in again. Whoops, I always do that. I see Jupyter Lab on the screen and I'm thinking, oh, I need to go there. Okay, boom. All right, we're all signed in. Excellent. Go back to Azure Data Studio, and we connect. And I shouldn't need to do this again because I already did, but might as well hit the play button and do the thing. Hello? Interesting. Oh. All right, well, let's just keep going. All right, so let's go ahead and get my nodes that I have here. This also gets a bunch of other stuff. This describes one of the nodes that we have. And you could see where, it's an Azure, it's definitely an AKS cluster. And I'm getting all this stuff straight from a Cloud Shell session in Azure. I could list my pods if I want. I mean, the possibilities here are endless. But I think the main point I want to describe here is that it's kind of treating Cloud Shell as like this secure environment, not so much secure, but just like an environment that like you and all of your coworkers could use as the environment that has every tool that we need, rather than having you install all the things locally. So this just gets logs. This one's vomits quite a bit out. Oh, looks like there's an error. I might have messed up the text at some point, but I think the point still stands. And then kube proxy logs. We got so many logs. I know this is a very long running task, so I'm just going to hit stop on that to cancel it. So that is another thing. So, geez, what was the next thing I was going to look at? Oh yeah, plotting. Plotting's definitely a fun one that I like to do a bunch. It's in this one. So I'm back in VS Code. This is a div file. Oh, I should also mention, if you wanted to see what this looks like, open reopen with text editor. It looks like this. These are the script which commands that basically tell you what the language is after it, which is kind of interesting. Anyway, let's show plotting really quick. And then I think I'm running out of time, actually. All right. So component status. This is a very simple example, but let's just see, we need a quick way to say, hey, is my cluster healthy in some way, shape, or form? And we can do that by running this. It's taking a little bit longer than I was expecting. Very suspicious. Something that I've noticed happens is that once I start sharing my screen or like streaming, is that it really bogs down VS Code sometimes. Let me just try this one more time from a fresh session here. There we go. Play. Ooh. There we go. Okay. Not really sure what that issue was, but all right. So we've run the thing. All this is doing is getting that data back, storing it in group data, and we use this group object command to like store results. So then we can make an actual pie graph and then plot it, just like this. And we could say, okay, it's all blue. It's healthy. Great. How about some other things? Let's look at the kube control events. I'm going to run through these because I have only a few more minutes left. We have 72 events. Let's plot them on a histogram by type. So there are 13 that are warnings, 59 that are normal. And if I wanted to, we can like drill into these further. This is pretty robust, what gets spit out here. Another thing that you can do is, if you are familiar with C#, for example, you can share objects between languages. So here I've got a PowerShell cell and I'm storing this variable. And then here I've got a C# cell and I'm saying, hey, I want to grab that variable from PowerShell. Give me it. And so from there, you could do something like this, where you're graphing a histogram of Kubernetes events over time. And you can see, over time, for some reason, there were 17 events right here. And there's so much more that you can do with this. It's pretty incredible. All right. I've got only a few more minutes left. So I've got like 2 more slides, but those are what I wanted to focus on. All right. I got to point out my use of PowerShell. A lot of you are going to get kind of scared that I was using PowerShell in this, but I hope that you could see that a lot of the commands that I was running were things that you would run in any other scripting language, really, like Bash, CSO, Fish. I know the syntax is a bit different, but for one-off commands, it usually should work the same. And I hope my examples have shown that. Who knows? Maybe, call me crazy, you might come to like the PowerShell syntax. It definitely allows you to do more with less code. And if not, go for it. Shell out to Bash. You could literally run bash-c and put your command in there right in a PowerShell cell if you so choose. Just another way to do it. My advice, take a look at the GitHub template and use that. I'm also looking for feedback on that if you have any. If you don't want to use that, or if you don't want to install Python, rather, use dibs. In time, they're only going to get better, and they already work in VS Code. That's the easiest way to get started. And also try Azure Data Studio if you do want to use IPYMBs and don't mind installing Python. So the next slide that I have is a big link of slides, also known as a big slide of links. And these are at the bottom of that GitHub repo that I shared at the beginning. And also, I just wanted to have a quick call out, like this thing called fast pages, which is this concept of taking notebooks and turning them into blog posts. And I actually do that with my blog, or my kind of half. I don't really put too much work into it, but this is a notebook that I wrote, and they have tooling to automatically turn it into a blog post. So lots of stuff, exciting times, and that's really all that I have to show you. I hope that was interesting, and I hope you could see how you might be able to leverage notebooks as a way for using notebooks for troubleshooting docs and onboarding docs and other things like that. Feel free to check out my book, Learn PowerShell in a Month of Lunches, if you'd like to get more context on that. And honestly, also take a look at all the Kubernetes books that Manning does. All right. Yes, I'm going to be in the Discord chat. Happy to answer any questions that you may have about this. It's definitely early days, but I think it's pretty exciting stuff that's happening. So, okay, I think that's it. I don't know how this gets passed over to the organizers, but I'm just going to magically hope that it says that if I say back to you.
Good afternoon. My name is John Guthrie. I'm a solutions architect at VMware, and I work on application modernization, usually with Kubernetes, which coincidentally is the name of my lightning talk today. So what am I talking about when I say application modernization? Well, let's say, you're a company and you've got this brand new Kubernetes cluster down in the machine room, and next to it is your current set of legacy servers, that's running all your current business software. So the idea is all that software that's running on all of that hardware right now, how do you get that over into your cluster, right? So how do you migrate your legacy software? Okay, so why would you do it is probably the first question you're wondering. And so there's kind of two sides to that coin. So one of them is, why are you modernizing from? Why are you still looking at this code that you have? Well, first of all, there's a lot of it, right? And it's full of a lot of smart stuff in it. You've got all this business logic that you've spent a lot of time perfecting, and it's all still correct. It all does what it needs to do. And you don't want to just walk away from those assets. And also, you've got these teams who've been building the software. They understand the software inside and out, and they probably understand the domain pretty well. So you have all these assets, And like I say, you don't want to just get rid of them. So I work with a group that we try and help you to take all of those assets and use them to get into your modern platform. So the modern platform, like I said, in this case, is going to be Kubernetes, right? So Kubernetes, you've got this new operational platform. It's Kubernetes. It's self-healing. It takes care of a lot of the pain points for you. You don't have to worry about old hardware that's going to be end of life, anything like that. But a lot of what comes with this, when you start doing this sort of modernization, is also there's just new ways of building your software. We do a lot of agile development when we try and teach agile development to people as well. So we do test-driven development for everything. And we do pair programming as well. So we emphasize these kinds of things. We emphasize robust unit testing all the way through, and doing this all in pipelines, right? So you have pipeline based. So it's a lot of the way GitOps works with the operational platform as well. So you're pushing code to a repository. It's running through a specific number of tests. It can be with the CI/CD. It can be promoted to production if you choose, or maybe there's some man in the middle who pushes a button and says it's all okay. But you're also pushing these artifacts that give you the repeatability. So you push into something like an Artifactory or something like that, and that's what drives your production platform. So all of this comes, it's not built into a Kubernetes platform necessarily, but this is just what modern application best practices is. And you're going to find when you do this that your employees are going to be very happy about this. You're going to have a lot easier time to convince people to work on a modern platform like this, as opposed to, say, trying to find somebody who can do Perl CGI or something like that. Okay, so how do you do this? How do we go through application modernization? There's 4 basic strategies, and they go from fairly easy to more difficult. And so let's take a look at this in this example here. I have a legacy. This is your current platform, right? And it's a standard 3-tier thing you built 10 years ago. So for the web UI, maybe you have a struts front end, Spring in the middle doing the service layer, and in the back end you've got Hibernate. And it's talking to a legacy database. And maybe over the years you've added some stuff to do like batch processing. You've added an enterprise service bus, so you got Camel or something like that running in there as well. It's all running in this one giant monolith, right? So the first way that we modernize is called replatforming. And in replatforming, basically you take this monolith and you put it in a container, and then you run it inside a pod in Kubernetes. And to be fair, you wouldn't just run a pod in Kubernetes. You're going to put it inside a deployment, and because you want the lifecycle orchestration that comes with Kubernetes. But basically, you've taken your monolith and you've just wrapped it in a container and thrown it out there. There's very little code change, if any. You have to do something to get it to talk to the database, maybe not. But this is it's pretty simple. It's a way to get a quick win, maybe, and to get people comfortable with the platform. So it's a pretty popular way to start doing modernization. The next thing you might want to look at is called refactoring. And in refactoring, you start to sort of tear the thing apart, carve out pieces of it. Most of the code still is exactly the way it was before. Maybe you still have this struts front end, but now it's running as a separate application, and you're talking to the services through a RESTful API or something like that. Again, you've done very little to change the software, but you're starting to break it apart. And you have a choice here. If you look at either one of these, a lot of times people will start with a replatform, and then as a next step, they'll refactor it out and start pulling pieces out of it. Sometimes you might go straight to just doing refactoring if you feel like you know what you're doing. The next one, though, is re-architecting. And in re-architecting, you're actually trying to push to a microservices architecture. So in this case, you start doing things like domain-driven design. So here we have a couple of bounded contexts, an employee service and a customer service. And So this is quite different, and you don't have the monolithic database anymore. They have their own separate data stores. I wanted to mention the first speaker today, his name was Matt Gross, gave what I thought was a really excellent talk about microservice architecture. So I'm not going to spend a lot of time here, but I would recommend you go back and talk and have a look at what he said, because he goes over all this stuff, especially like the domain-driven stuff and how these things communicate. But like I said, you can see here that we've created bounded context to the back end, and we've taken like the enterprise service bus, and maybe we're using some of the modern stuff that we have here. So we're using Knative, or we're using Kubernetes jobs or something like that. Another thing that happens when you start re-architecting is you can start looking at different technology stacks here. So the web UI, now you're going to use something like React or something like that, right? And so no longer do you have to have homogeneity amongst all your code base, because it's not a monolith anymore, and it's logically designed. And then the last one is redo. And redo is pretty much the same as re-architect, except that the complexity of your code or something about it just didn't really lend itself to reuse. I should have mentioned earlier when we talked about re-architect, you're probably keeping your business logic, just putting it inside these different services, these different microservices. But with redo, there's just, maybe that's just not a good route. So your old application just goes into the flaming trash can and you start over. This is what you call a greenfield deployment, right? So that was pretty much it. That was my whole lightning talk. I wanted to mention that a lot of what I've shown you here there's a live project on Manning that I created called Converting Legacy Applications to Cloud Native in Kubernetes. And we go through these steps. We take a legacy application and we basically re-platform it and refactor. We do sort of the first two of those options. And so you can find that at that URL. My email is above that. If you want to ask me about anything, you're welcome to. And I think I took a picture of my LinkedIn there. So you can probably find me there as well. And that's all I had. So thanks a lot.
All right. Hello there. My name is Dan Garfield. I'm the Chief Technology Evangelist for CodeFresh, a CI/CD DevOps platform built on and for Kubernetes applications. I'm going to be showing you a demo today of how we can run builds behind the firewall. Just to introduce myself, I am a Google Developer Expert. I'm also a member of the Forbes Technology Council, and you can follow me on Twitter at @TodayWasAwesome. So let's just jump right in. There's this common problem that exists, which is how do we run builds or infrastructure behind the firewall? And lots of times this is for security reasons. People need to have full control of their infrastructure for compliance or security or other kinds of things like that. And they end up running full on-prem instances of older software typically, or more limited software, that they then have to manage and maintain and update and keep secure. It's actually very common. It's actually a big security issue that people running CI/CD or CI tools specifically on their own infrastructure commonly actually have things that are out of date and have security vulnerabilities and things like that. So what began as a security issue for the reason and motivation to keep that stuff on-prem actually creates oftentimes security issues. So what we did is we created this tool called the CodeFresh Runner, and what it allows you to do is run all of your builds or do deployments or access secure resources behind the firewall without having to maintain the entire stack of CI/CD infrastructure. And we do this by taking advantage of Kubernetes primitives to make not only virtually zero maintenance, but also incredibly fast builds. So you can see a diagram of how it works here. You basically have the runner running on a Kubernetes cluster, and this could be on-prem, this could be in a virtual private cloud, this could be on your laptop, it could be basically anywhere. This could be on a boat in the Pacific Ocean headed for the coast. And this runner will manage itself and self-update, and it will have access to potentially a secure registry or secure Git, secure databases or other resources that are on the firewall, and none of that will exit the on-prem instance here. This will connect to basically you can think of it almost like a service mesh of sorts. It's basically a way of managing multiple runners and setting configuration and things like that. But it doesn't require any open firewall ports going in. The CodeFresh runner will only call back to look for jobs or things like that. So let's take a look at it. This is on the CodeFresh website. I've set up a demo cluster here that we're going to take a look at. But to install this, all you have to do is install the CodeFresh CLI. Now we do have Homebrew and a few other supported package managers available. And then you just run CodeFresh runner init. Now, what I'm going to show you right now is actually a scalable way of doing this. So here I've got a cluster set up that has 2 nodes. Now this one's on GKE, but this could be just as well on Azure or Amazon or anywhere else where you might have node scaling enabled, because I am going to do some node scaling here. Now you don't have to have node scaling, but it is a nice feature. One of the cool things about this is I'm actually going to be doing this very much on the cheap, because these nodes here are all what are called preemptible nodes. Now, if you're coming from Amazon, we call those spot instances. Basically, these are nodes that can be destroyed and taken away by the cloud provider at any time. Now, if that sounds scary, it is. If you don't have the underlying infrastructure to support it, of course, you could end up with workloads being destroyed. But in this case, because we're using the runner, I can basically spin up and run jobs, and I can spin up new nodes on demand and let them fall off and go away as needed, because it's essentially a scalable, flexible way of doing the infrastructure. So it's very inexpensive, and it's actually surprisingly fast. So let's get into it. I'm going to clear my screen here, and to start installing the runner, I'm going to do the CodeFresh runner init. This will take me, oops, I meant CodeFresh runner init. This will put me into the installation procedure. And I can see all my Kubernetes clusters here that I have added to my local kubeconfig. I'll select the one I want to work with. I will let it create the Kubernetes, the CodeFresh namespace. I do not want to replace my default runtime, and I do not want to run a demo pipeline. All right, so this is going to go ahead and install the components. Now, why are we using an installer versus just applying a Kubernetes configuration? Well, the actual reason for this is because I'm using the CodeFresh CLI is actually creating a token on the back end that's attaching onto the runner. And then it is also actually generating certificates that will allow the runner to talk securely back to the CodeFresh interface. So here now I can see that the installation is completed. Looks like all the components should be installed. If I do CodeFresh, if I do kubectl git pods and look at CodeFresh, we should see the components beginning to start here. It looks like we've got everything running properly. Now I'm going to go over to the CodeFresh UI, and I'm going to pick my a simple pipeline. This one starts a Redis instance, and then we actually push some data to that service that's running, and then we read some of that data. It's just a demo pipeline. It's really simple. On the settings here for the runtime, I'm going to go ahead and specify the runtime that I just installed. It should be this third one. You can see I've been demoing around with this a bit today, and that should match exactly what we see here. All right, cool. Now, one of the things that I did here is instead of running builds one at a time, I actually created a simple script that will spam pipelines. And the way it works is it basically takes a number, and it will do a loop where it says CodeFresh run the pipeline that I just said, and it will do it as many times as I have specified. So I'm going to do spam pipelines, and let's run 10 of these. Now, we'll see these actually show up in the CodeFresh UI fairly quickly, so we can see that these are starting to actually show up here. We're getting IDs back. Now, this cluster, because I'm using very small nodes and I have node scaling enabled, it actually can't handle the number of pipelines that I'm trying to schedule onto it. So what we're going to see here very shortly is that as pods start spinning up to actually run this job, and you can almost see it if I just do kubectl git pods CodeFresh here. You can see it's actually trying to schedule all these different pods to run all these different pipelines, and it doesn't have the overhead in the cluster to do so. So now we have a bunch of these are pending. Now we can see some of these are actually running, so we can pop those open and see that they've just started to initialize. I've noticed that Google's auto scaling tends to take
60 to 90 seconds before it recognizes that it needs to start scheduling more before it starts scheduling more nodes. But it happens relatively quickly, so we should see those start to pop on in a moment. One really cool thing about this, I'm actually looking at the status of a build that's happening on this cluster that is behind the firewall. It doesn't have, CodeFresh doesn't have any connection to that cluster, so the data that it's getting is actually being reported back to CodeFresh from the runner. So here I can see it's just an initialization. This makes sense. As we've just tried to schedule a whole bunch of things, we'll see that it's a little bit slower to start. We do see that another node has been added on to start taking some of those jobs off. If we come back to our builds here, we should be able to see that our pending is now 7. We've got 4 running, and we'll see those start picking up further and further. Another cool thing about this is, and of course I've just spammed a whole bunch of jobs into it, so it's going to take a second for everything to get going. But one of the other cool things about this is, for any of you that have used CodeFresh, you know that we have this feature called live debugging, which allows you to set breakpoints in a pipeline, and you can actually drop into an interactive shell in and out of containers. So you can move in containers and out of containers and work with the shared volume and figure out exactly what's going on. That's actually compatible with the CodeFresh runner. I'm not going to demo that today, but if we were to run one of these pipelines in debug mode, we would see that actually fire off. So now I should see just the beginnings of some of these starting to actually finally initialize here. As it is the first time I've run it on this cluster, it is going to take a little bit longer than it normally would. Now in production, what you'll actually see is that you'll have sort of a minimum number of nodes that are actually running. And so the scale component, even if that takes a minute or two to start, it's not that big of a deal because you actually won't usually hit it that often. It's more just going to move up and down kind of throughout the day as needed. And oftentimes you're not necessarily noticing and looking directly at the pipeline while it's happening. So that's essentially the thing. These are going to run, and we've got now 1, 2, 3, 4, 5, 6, 7 nodes. So that should be able to handle those 10 jobs with ease. And yeah, that's basically the CodeFresh runner in a nutshell. You're able to run these pipelines and jobs very quickly on the infrastructure. Now, of course, if these were accessing behind the firewall components, such as a Git instance or maybe an Artifactory or something like that, they would of course be able to access those components in a secure way, that just like you'd expect. So you can try this for free by going to codefresh.io, and actually you can see there's just a simple a call to action down here. Learn about the runner, you can do it there, or you can look at our different ways of running infrastructure down here, and you can pick the CodeFresh runner. And just need to install the CodeFresh CLI and initialize that CodeFresh runner, and you should be good to go. So thanks again, really appreciate you joining and checking this out. We can watch one of these pipelines in action here and see it actually started up that Redis database. It's running. It stored some data. It's basically just running some dummy jobs in here. So with that, I will leave you to try this on your own. Go to codefresh.io, try out that runner. It's pretty cool. Works with clusters, even just your laptop. Just throw it on Minikube or Docker desktop or whatever, and you can start running builds, unlimited builds on your own infrastructure today. So enjoy. Thank you.
With CodeFresh, we've rethought the CI/CD build and release process from the ground up for the world of microservices. As you adopt microservices, the number of pipelines you need to create and maintain skyrockets. Old build systems can't scale to meet the demand. But CodeFresh allows you to standardize your steps and package them in Docker images, then reuse them across multiple pipelines. You can think of them like a library of building blocks to build images, perform canary releases to Kubernetes, launch serverless functions, do security scans, UI tests, and so much more. And since the steps are Docker images, you can very easily create and use your own private steps or use images contributed by the growing CodeFresh community. Traditionally, the CI/CD experience has been pretty unfriendly, but we built CodeFresh to be a tool we actually want to use with a beautiful and functional UI throughout. In CodeFresh, you not only see pipelines and builds, but you also connect directly to your runtime environment and see what services you've deployed, and you can trace them back to the code and configuration changes, as well as seeing who worked on them and how they were validated. CodeFresh has an embedded Docker registry and Helm repository with integrations to all your external registries, so it's easy to manage and promote images and charts. When teams adopt CodeFresh, they release more often, and their engineers have more time to build their product, rather than building pipelines. That's why enterprises and startups alike love CodeFresh. Go to codefresh.io to create an account so you can start building your own pipelines, or schedule a one-on-one with one of our CI/CD experts to help you get up and running quickly.
Rancher is the market leader in open source cloud-native Kubernetes management and allows you to manage and scale workloads consistently across thousands of clusters in any environment and support any certified Kubernetes distribution. Monitor the health of all your clusters through a single pane of glass. Simplify and automate the deployment and management of containerized applications. Deploy persistent storage with just one click. And simplify global access control and security policies for your entire Kubernetes environment. And because Rancher is 100% open source, you can achieve all of this at a fraction of the cost of legacy solutions. Kubernetes is the key to unlocking digital transformation. Rancher is the key to unlocking the full potential of Kubernetes. Schedule your free no-obligation consultation today.